Good morning, everyone. Thank you for waiting patiently. We are beginning shortly. A very good morning to each one of you. Welcome back to day 2. And what a delight it is to see this gathering once again. Well, if you're here, it means 3 things. You're curious, you're committed, and maybe you didn't hit snooze too many times. Well, they say the best conversations are the ones we return to. And today, we pick up the threads of thoughts we began weaving yesterday. We begin today with the session on new age technologies. It's going to be a forward-looking exploration of new age technologies redefining the mineral industry. As AI, Internet of Things, and space mining find increasing relevance, this session showcases how innovation is no longer optional. It's the new lifeline of mining sustainability and efficiency. I would request Dr. G.K. Pradhan, Professor and Dean, AKS University, and Sri Rajesh Bhattacharya, Joint General Manager, to kindly chair the session. May I please invite Dr. G.K. Pradhan and Sri Rajesh Bhattacharya on stage?
Thank you, ma'am.
Thank you. And I would invite our first speaker, Mr. A. Janardhan, to kindly present on world's largest HPGR.
Please introduce yourself.
Yeah, sure, sir. Namaskar. Good morning, all.
Good morning to all of you. Respected Kulse Saab, Kale sir, and all my colleagues and all dignitaries, Mera Venkataya Saab, my student Naniwal ji, Gurdeep Singh ji. देखिए स्टूडेंट बने तो स्टूडेंट बोलना पड़ेगा यानी गुरु बनने से तो नहीं चलेगा क्यों सर so with all your gracious presence we'll start the session. Over to the speaker, please introduce yourself. कहाँ से पास किए क्या क्या किए बता दीजिए.
Yeah. Namaskar. Good morning, all. My name is Janardhanan. I am from FLSmith, FLS. I've been working with FLS for last 17 years, and we are into mining and cement industry. And FLS is a Denmark-based company and original equipment manufacturer, serving mining industry for more than 140 years. So this session is all about technology and sustainability. I'm here to present one of the latest technology, which has been there globally for a very long time, but now is picking up pace in India. It's HPGR for mining industry in India. High pressure grinding rolls. So before we get into this technology, let's see what are the evolving needs of mining industry. So when we really look into the mining industry in India, what do we want? What is the need of an hour? So if we try to define that, there are 2 things. One is productivity, which is try to get more from the same, and the other is the sustainability, try to get more with less. So if we look into productivity, there are 3 things. One is the runtime. The plant has to be continuously operated for the longest possible period, and the recovery of the ore needs to be increased. and third is the throughput of the equipment what we are operating in the plant. And sustainability, we need to achieve all those productivity with the as low as possible energy consumption, water usage, and emissions. So we will now see how this HPGRs is contributing to the mining industry. So this is the agenda for the day. We will look into the basic operation, how the design construction of an HPGR is, and what are the simple factors of operating the machine. So if we look into HPGR, this is the design construction where we have a feed bin where the material is stored, the ore is stored, and the ore is fed in between two rollers. We call one as the fixed rollers and other as the floating rollers. On the floating roller side, there are 4 hydraulic cylinders, this side 2 and that side 2. Both these rollers are driven using a gearbox and motors and controlled via variable frequency drive. And there is a housing and feed control gate is there to let the ore in between the rollers. So the basic operation is both these rollers are operated using motors on a counterclockwise direction where the material is fed, and the floating rollers is connected via 4 cylinders, and the 4 cylinders are connected to a nitrogen cylinder where the pressure is preset. When the material is drawn in between and both the rollers are rotating, the material pushes the floating roller back, thereby creating a pressure in the system. And when the working gap is achieved, then we call it a comminution process through interparticle breakage. The high pressure is applied on the ore and the ore gets reduced to the size fraction what we required. Two simple operations, control operations required for an HPGR. Since both the rollers are connected to gearbox and motors through variable frequency drive, we have roll speed. Higher the roller speed, increase in the throughput capacity required, and lower the speed, we can reduce the throughput capacity required for the plant needs. Press force is basically increasing the hydraulic pressure of the system, means finer is going to be the discharge. The product fineness is going to be higher. And lowering the press force means coarser the ore size reduction as per the plant needs. So HPGRs have been in the market for more than 40 years and have been used in many industries. Like cement has been there since 1980s, early 1980s, but it was introduced in mining somewhere around early 1990s for a diamond industry, and it did a phenomenal job. But still there was some challenges with respect to the wear, because as we know, the ores are highly abrasive in mining. The roll surface could not last more than 4 or 5 months. Then late 90s, development of studded rollers, roll surface as a wear solution came up, where these studdeds are tungsten carbides, high studs, high hardness studs, which are used on the roll surface. And during the operation process, the material gets stuck in between these studs. So thereby, even though these high cost, high efficient tungsten carbide studs are only covering 30 to 35% of the roll surface, the rest of the surface gets covered by the material ore itself, forming an autogenous layer, thereby extending the wear life to the required level of more than a year. Then on HPGR landscape, we see FLS experience and how many install base we have around the globe for different material applications. So FLS has been supplying HPGRs for more than 40 years. We have more than 170 numbers of HPGR installed across the globe for various material application, including molybdenum, iron ore concentrate, gold ore, copper, diamond, kimberlite, and platinum and rock phosphate or limestone, you say any ore HPGR can handle with ease. So FLS has more than 35 years of experience in supplying HPGRs and operating it successfully. And the machine can treat truly hard ores, and it's a field proven wear surface now. It has achieved a plant availability of more than 90 to 95% HPGR alone. And the machine can be pre-assembled to the maximum extent possible in the workshop so that the erection at the plant can be done with ease. FLS has the highest market share in this equipment segment. We have, especially when we take larger roll diameter, more than 2 meters, we have 91% market share. And when considering hard rock or abrasive ore applications, we have more than 80% market share. So when we say about HPGR installations, one project gets highlighted where we call this as industry standard for HPGR for Serravaada plant. It is a copper concentrate having a plant production of around 360,000 metric tons per day. This plant started in 2006, where we supplied 4 numbers of HPGRs with 24/17, which means 2.4 meter roller diameter with 1.7 meter roller width. It's a breakthrough installation for hard rock in mining, and the same customer expanded the plant in 2015 with additional 8 more numbers of same size HPGRs. So this PM8, what we call, we have almost 56 numbers of same size machine installed with so many plants in mining industry. Now, in future, we will have one more industry standard, what we say the world's largest HPGR. Lloyds is coming up with phase 1, 2 into 15 million ton per annum plant, and phase 2, 1 into 15 million ton per annum plant for iron ore. And it is going to be again a breakthrough application for BHQ ore. And this machine, 30 by 20, 3 meter roll diameter with 2 meter width, is having a throughput capacity of more than 6,000 tons per day. And it is capable of reducing the feed size material from 50 mm to less than 3 mm, and in the most efficient way. Apart from supplying machines for greenfield, brownfield expansions, FLS has also used this technology to improve the plant productivity by installing this machine in the existing flow sheet in an operating plant after the secondary crusher or a tertiary crusher, further reduce the size before it goes to the final grinding in ball mill, and thereby increasing the production by 15 to 20%. This is one such example of plant upgrade in 2005 in Indonesia, and another in CS Tokapella mine, again for copper ore. You have supplied an HPGR after the tertiary crusher, and it has increased the plant productivity by almost 19%. So when we say this 19%, how does it turn into a return on investment? Because most of the times, finance is extremely critical, and they keep an lens on how does it benefit the plant and what is the return on investment. So we did try to calculate how this 19% increase in productivity contribute, and we made that calculation. This was done in 2015. That time the copper ore was around $5,000 per ton. And today, you know, it has already gone up to 10,000 tons per day, 10,000 tons per dollar. So the total investment cost of this project was $50 million then. And per year, this 19% translates into $104 million, which means less than 6 months recovery. And today's copper rate, it can be even less than 3 months. We look into flow sheets where this technology can be employed, because it's a very versatile technology and it can be used in many places in the plant flow sheet. So one is the primary grinding, which is after the primary crusher and secondary crushers. We use this machine to effectively downsize the ore before sending into ball mill. So replacing and today the tertiary cone crushers are used instead of HPGRs, but globally mining plants have started moving towards HPGR in place of tertiary cone crusher. So if you look into the product size distribution, after the machine, the ore size reduction, what it has attained, this line is the cone crusher size reduction, particle size distribution, and the material that comes out of HPGR, you can see it has much higher fineness compared to cone crushers, and it also uses low energy for doing this higher size reduction. HPGRs are also many times in the mining plant, the crusher packages are being installed in the mines, primary, secondary and tertiary, and then it is sent to the plant. So instead of disturbing the existing tertiary crusher, the HPGR can also be utilized as a quaternary crusher stage where the tertiary cone crusher product is sent to HPGR and further size reduced before sending into ball mill. So this actually helps in reducing the particle size to the mill, also lowering the bond work index. Since HPGR operates at a much higher grinding pressure, between 2500 to 4500 kilonewton per meter square pressure, it helps in reducing the bond work index of the ore. Thereby, the power consumption on the ball mill is reduced and the productivity can be improved. And it also generates a lot of fines, thereby increasing the final product percentage. And the latest high efficiency comminution is, which is coming up in Lloyds, has HPGR on the tertiary side and followed by FTM in the primary grinding, Fuller Tower Mill, it's a verti mill, wet grinding, and again a secondary grinding, wet grinding tower mill. This high efficiency comminution circuit, we call it reduces almost 30 to 50% of power consumption compared to the conventional ball mill circuit or sag mill circuit. There's also future which is coming up on the dry grinding side, because there are many regions around the world, especially Australia, we know there are so many mines available, but there is also water scarcity which is popping up, which means we need to go for a different circuits like dry grinding circuit. So we can utilize either HPGR in the dry grinding circuit, or we can use a vertical roller mill for reducing the size to the required product fineness. HPGR, we have complete product range from PM0 to PM10, that is 500 kilowatt installed power until 2 into 5 megawatt installed power. Lab testing, FLS has extensive experience on lab testing of the ore. We have different machines for lab testings. We use Atwal for abrasion test work, and we use Margo for semi-industrial scale test work, so that the proof of concept is done and the investment on the capital side of the machine is completely secured. Then we have also made a comparison, because when we bring in a new technology into picture, there is always a trade-off study. Many plants who they are used to dealing with sag mills, ball mills, then what about the existing technology and how does this work? So we need to do a lot of trade-off study. One such trade-off study was conducted on copper ore, a 3 million ton per annum, where there is the traditional circuit, sag mill with ball mill concept is there, and instead of this, we are giving high efficiency HPGR circuit where it has a cone crusher on the secondary side and an HPGR followed by a ball mill. So how does it work? We take the material from the primary crusher, and then it is put into the screen where less than 45 mm, which is created in the primary crusher, already gets come out of the screen, secondary screen, and goes to HPGR directly. Above 45 mm material goes to the secondary crusher, and gets ground, again goes to the screen, and the HPGR operates less than 50 mm, 45 mm, and then it is connected with a screen of 5 mm cut size. And this, how does it translate into, because we are adding an additional equipment compared to a single equipment. So how do we justify the investment? Then we did a complete operational expenditure and CapEx, capital expenditure comparison. What are we changing? So this is the one SAG mill required, where we have put the CapEx all on the index basis. So SAG mill, most of the time when we do comparison, we keep the grinding media out of the picture, but which is actually more critical to include grinding media in the comparison, because it is a very high operational cost and consumable wear part. So SAG mill is around 100 if we say, then HPGR looks like 78, screens required for the secondary and tertiary is around 11, and cone crusher is 7. So the capex wise, there is really not a big difference. We are neither saving nor it's very higher. It's almost same. But if we look into the operational cost, the power, the grinding media or spare cost or the wear parts cost, if we look, there is a huge potential savings we can make with this alternate circuit by using HPGR technology, which will save almost 30 to 40% of the operational cost. So when we did the math for a 3 million ton per annum copper ore plant, it translates to around 120 crores per year of operational cost saving, and it is huge. So thereby, when we do this trade-off study, we get to know exactly which technology is better, and FLS has both these technologies, but we want to put the best to the owners so that you know the right one to pick. Yeah, thank you all. This is what I had covered my presentation.
Excellent presentation in time. Okay.
Thank you.
Venkatesh Saab has got a question.
Yes,
Pass on.
yes, sir.
So we'll take the questions at the end of the session with all the speakers.
If you have the time, you can
There are
finish it.
few papers only.
So we're already running 3 minutes late.
Okay, okay, please. Okay, please. Thank you very much.
Thank you.
Proceed.
Thank you.
Or those who want to make questions, please make it in a piece of paper so that he can prepare the answers in advance. Next paper is Mr.
Our next speakers are Ms. Daksha Vyas and Ms. Rutuja Dhingre, and they'll present on Can Space Mining Support a Sustainable Future?
Since yesterday I found out an interesting part. There are two, yesterday there was a drone paper, wonderfully presented I am telling you, and the effort put by our lady presenter yesterday, professor, so nicely she explained. If she would have got exposure to 2-3 mines, she would have made it much more attractive for all of us. I hope you will also make a better presentation. Go to the space. Introduce yourself.
Good morning, everyone. I am Daksha Vyas from PG Department of Nagpur University, along with my co-presentator, Ms. Rutuja Dhingre. I am delighted to begin our presentation on the topic, Can Space Mining Secure a Sustainable Future? These are my contents. What is space mining? Space mining refers to the collection of useful materials from outer space. These materials can be taken from moon, asteroids, and other planets. Scientists and engineers use robots or spacecraft to go to space and extract metals, waters, and other resources. Some asteroids have valuable metals like iron, nickel, cobalt, or even gold or platinum. The moon may have the water ice and special element called helium-3, which could be used for clean energy in the future. Space mining is being studied because Earth resources are limited, and space has been untapped material. It could also help us to live and work in space without depending on only Earth. Resource and sustainable needs. Resources are natural things we use every day, like water, metal, oil, and clean air. These help us to live, build houses, make products, and produce energy. But many of these resources on Earth are limited. If we keep using them too fast, we may run out. This is why we must use them carefully and think about the future. Sustainable need means to use resource in a smart way so that future generations have also enough. This includes saving energy, recycling, finding new ways to get resources from space. Challenges and benefits of space mining. Benefits of space mining. Space mining can give us new resource of important material like iron, nickel, gold, and rare metals. These are used in electronics, clean energy, and space technology. It can also provide water and fuel for astronauts, making space travel easier and cheaper. By using resources from space, we can reduce pressure on Earth-limited resources and support future space missions. Challenges of space mining. However, space mining is not easy. It is expensive to build records, machines, and send them to space. The technology for mining in space is still new and need more research. There is also safety risk for astronauts and robots. Bringing material back to Earth is difficult and need a careful planning. Finally, there are questions about who owns space resources and how to share them fairly. Regulatory frameworks. Right now, there are few clear rules about space mining. According to Outer Space Treaty 1967, space belongs to countries and no one can claim land in use. But countries like USA and UAE have started making their own space mining laws. We need global agreement to decide how to explore and use space resources in a peaceful and fair way. Ethical frameworks. Ethics means doing right thing. In space mining, this means not harming other planets and space environment, sharing resources fairly among all nations, making sure mining does not lead to war or conflicts, protecting space for future generations. Space could be used for peacefully and sustainable purpose, not just for profit. For further discussion, I would like to invite my co-presentator, Ms. Rutuja Dhengre, to take you through an insightful journey of exploring how space mining could help us meet the resource demand for the future. Thank you.
Thank you, Daksha, for the great start. Hello, everyone. My name is Rutuja Dhengre from PG Department of Nagpur University, and I'll be taking you further for the second half of the presentation. Now, let's look at how exactly space mining could help us. Some asteroids in space are richer in precious metals than Earth's crust. In fact, even a small metallic asteroid could contain trillions of dollars worth of resources, sometimes more than the entire annual global economy. Imagine extracting these high-value materials without destroying forests, polluting rivers, or displacing communities, which often happens with terrestrial mining. That's a major step toward environmental sustainability. But that's not all. Resources like water ice found on moon or asteroids can be converted into rocket fuel or life support system, such as oxygen. This means we could refuel spacecraft in orbit or build long-term space missions without having to carry everything from Earth, significantly reducing mission costs. Next is current developments and industry momentum. This isn't just science fiction. Real progress is happening now. Companies like Astroforge and TransAstra are already developing asteroid mining technologies. NASA is testing robotic systems like RACER and IPEX to extract lunar resources such as water and oxygen. These innovations are laying the foundation for commercial space mining in the company's decades. Next, governance and sustainability policies. Although not yet official, there are talks about a Sustainable Development Goal, SDG 18, focused on space sustainability. It will address fair access to space resources, space debris management, and environmental protection beyond Earth. Such policies will be crucial as we move forward. Next is from asteroids to Earth. Let's look at missions that have already brought back space materials. First is Hayabusa and Hayabusa 2. Japan's Hayabusa missions collected samples from asteroid Itokawa and Ryugu. They found silicates, iron, water-bearing minerals, and organic compounds, proving asteroids hold useful materials. Second, OSIRIS-REx. NASA's OSIRIS-REx brought back 120 grams from asteroid Bennu. The sample contained water-rich clay and carbon materials, showing asteroids have life-building elements. Third, lunar samples. Apollo missions and Chang'e 5 brought back moon soil and rocks. They found ilmenite, helium-3, and oxygen-rich regolith, useful for further space resource. These missions prove that useful and even life-building materials exist beyond Earth. In conclusion, space mining offers a revolutionary path to sustainability. It can unlock new resources, reduce damage to Earth, and enable deeper space exploration. But we must address its challenges, especially governance, ethics, and technology. If handled responsibly, space mining can truly support a sustainable future for all. Thank you for your attention.
Thank you very much. जब space mining का बात आया, we remember S.B. Ali साहब. S.B. Ali साहब in 1990s wrote a book on space mining. 100 पन्ने का किताब था, and it बड़ा हल से it created lot of ripples in the mining industry. Mining India में Earth में छोड़ के आप क्यों why you are going to the space? But after long gap, when I find the presentation, I remembered Ali Saab. He was, I think he was a regional controller of mines in IBM. Thank you very much. Over to the next paper.
Next speaker is Mr. Kaustubh Deshpande, and he'll present on transforming mining waste into sustainable nanomaterials.
Myself, Kaustubh Deshpande. I am delighted to talk on transforming mining waste into sustainable nanomaterials, techniques, application, and economic potential. I am a research student, and I have not directly worked on this paper. This is purely literature review work. These are my frame of presentation. Introduction. Mining is crucial for industrial, technological, and infrastructure and healthcare. India generates around 170 million tons of mining waste every year, which increasing due to lower overgrades. Common waste type, which includes tailings, slags, acid mine drainage, and overburden. Traditional disposal methods such as tailing dams, and landfilling are often unsustainable and cause long-term ecological damage. Nanotechnology offers innovative ways to transform mining waste into valuable products. Nanomaterials are classified into two types: nanoparticles, which are around 1 to 100, which are of dimension around 1 to 100 nanometers, and nanomaterials are the substances which have their one dimension in the nanometers. Nanoparticles are mainly used in cement industries, coating industries, as well as for drug delivery. Along with this, they are also used for environmental remediation as well as biomedical application. They are also used for antimicrobial coatings and catalysts. These nanoparticles are derived from mine tailings as well as acid mine drainage, as well as also they are derived from slag and smelter residue, coal mine waste, and RE deposit waste. Nanomaterials are derived through physical methods as well as chemical methods. Physical methods include high energy ball milling, in which mine waste is reduced to the nanoscale through mechanical grinding, making it effective for producing silica, titanium dioxide, and iron oxide nanoparticles for mine tailings and slags. Ultrasonication and laser ablation utilize high frequency sound waves for laser pulses to break down solid materials into nanoparticles, generating copper, silver, and zinc oxide nanoparticles from mining residues. Chemical methods include solvent extraction and chemical precipitation. In solvent extraction and chemical precipitation, mainly mine waste is treated firstly with acid, and then nanoparticles are manufactured using alkaline agents such as sodium borohydride, sodium hydroxide, etc., yielding iron, copper, and rare earth element nanoparticles. Hydrothermal and sol gel synthesis involves high temperature and high pressure conditions to transform mine derived metal oxides into nanoparticles, effectively producing silica, alumina, and titanium dioxide nanoparticles from fly ash and slag. Electrochemical reduction and oxidation, which is a most efficient method for production of nanoparticles, where metal ions from acid mine drainage or tailings are reduced through electrolysis, leading to the recovery of gold, silver, and platinum nanoparticles. Although chemical methods are there, but they are energy intensive, environmentally costly, and economically costly. Therefore, it is suggested to use green synthesis as well as microbial synthesis. Microbial assisted synthesis use bacteria such as Pseudomonas aeruginosa and Bacillus subtilis facilitates the biosynthesis of gold, silver, and iron oxide nanoparticles. Plant-based synthesis leverages plant extracts from sources like aloe vera, neem, and green tea, which act as natural reducing agent to form zinc oxide and copper oxide nanoparticles. Enzyme and protein media synthesis employs biological macromolecules to control the reduction and stabilization of silver, selenium, and iron oxide nanoparticles, making this technique highly sustainable for biomedical application. Applications of nanoparticles are applied in the construction industry as well as in environmental radiation and medicine and biomedical applications. Nanosilica and nanoalumina are used to improve cement hydration, compressive strength, and durability. Nanotitanium dioxide used in self-cleaning and pollution-reducing coatings. Iron oxide and magnetite nanoparticles are used in magnetic separation techniques to remove arsenic, lead, and mercury from water. Zinc oxide and silver nanoparticles exhibit strong microbial properties in wastewater treatment. Gold and silver nanoparticles are used in targeted drug delivery systems for cancer therapy. Titanium dioxide and hydroxyapatite nanoparticles applied in orthopedic and dental implants to enhance biocompatibility and bone regeneration. Nanoparticles have economic benefits also, which are they increase energy storage as well as renewable energy technologies. They are also used in electronic and sensor technology. They are also used in coatings and textile industries. Economic benefits, they are cost effective for raw material production. They also create jobs, as the global nano-enabled construction materials market is projected to reach $20 billion by 2030, driven by sustainable infrastructure projects. Energy savings and improved efficiency. Nanomaterials such as graphene, lithium, iron and phosphate, and quantum dots enhance the performance of solar panels, batteries, and fuel cells, leading to lower energy cost and increased renewable adoption. Environmental benefits, they give resource efficiency and circularity. They also reduce the disposal cost of mining waste. They also have positive externality which improves air and water quality, enhance land reclamation, and reduce greenhouse gas emission from waste storage and treatment. Contribute is societal benefits. They also provide market diversification and also lower the environmental remediation burden. They also have environmental benefits such as waste reduction and pollution control. They also reduce carbon footprint. They also have sustainable resource management, and they also improve water and soil remediation. There are also challenges for the production of nanomaterials from mining waste. These are technical barriers, which include complex purification methods and stabilization methods. Economic constraints, high initial investment cost deter industries, and regulatory gaps. Standardized policies for recycled nanomaterials are needed. Future perspective, advancements in extraction and processing technologies, integration with circular economy and models, development of international standards and policies, emerging applications, and market growth is required. Summary, the recycling of nanoparticles from mine waste offers a sustainable and economically viable approach to waste management by converting mining residues into high valuable products across multiple industries. Mine waste, including tailings, slags, and mineral-rich residues, serves as a significant source of recyclable nanoparticles such as silica, iron oxide, titanium dioxide, zero-valent iron, and metallic nanoparticles. These materials can be extracted and synthesized using techniques such as mechanical milling, chemical leaching, magnetic separation, and green synthesis methods that utilize microorganisms and plant extracts. The repurposed nanoparticles have broad application in construction where nanosilica improves the durability, strength of concrete, and iron oxide nanoparticles contribute of self-healing cement. In environmental remediation, zero-valent iron is widely used for water purification and soil decontamination, while iron oxide nanoparticles aid in wastewater treatment and oil spill cleanup. Additionally, in the energy sector, recycled nano-copper and nano-silver are crucial in manufacturing batteries, solar panels, and conductive coatings. Other applications include advanced coatings where nano-zinc oxide and nano-aluminum enhance corrosion resistance, and biomedical uses where gold and silver nanoparticles have antimicrobial and drug delivery applications. These are references. Thank you.
Thank you, Professor. Please. What is your research area?
My research area is about geochemistry.
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 You have got good exposure to biotechnology department also?
No.
Find out from somewhere.
Okay.
There are plenty of biotechnology colleges here in Nagpur itself.
Okay.
Be interactive with them. With geochemistry alone cannot work. You
Yes.
take them into confidence. Okay?
Okay. Thank you, sir.
We'll now invite our last presentation for this session from Mr. Anand G. Sangore on blast-induced rock fragmentation.
Good morning to all. I am very happy that I am presenting paper in front of the blasting expert, chairman of today's session, Dr. G.K. Pradhan. So yesterday, some of our senior colleagues have presented in underground mining technology, but in our Nagpur Research Center, in Simpar, Nagpur, we are also carrying out a study regarding blasting, regarding subsurface seismic subsurface profiling, and explosive testing, and all those study we are carrying out. So my today's topic of the presentation is blast-induced rock fragmentation review. Actually, blasting is day-to-day activities, and there is lot of development is going on. So from the industry, so many queries are coming that why not to carry out studies in the fragmentation, because fragmentation is such an area where a lot of economics is involved and lot of cost saving is involved. So introduction. So in this, in the diagram, there are so many blasting variables are involved, like burden, spacing, then your stemming, then the whole dia, and these are the bench space. So here, this in situ block size nothing is between it is a block in between the joints. So these are naturally occurring. And in my study, one of the case study I have taken of ACC, so I wanted to tell you that what is the relation between this in situ block size and after blasting whatever the muck we are getting. So what is the correlation in between, and how can we measure the blast fragmentation, and what are the prediction technology available in the mean fragment size prediction. So now I'm starting with this fragmentation. Fragmentation is nothing but what muck pile we are seeing here in the muck. So fragmentation we are measuring in the mean fragment size, and another parameter is the uniformity index. Uniformity index is nothing but how your muck pile is uniform. There should not be more boulders or more fines. If some more boulders are there, then you have to go for the secondary blasting. If more fines are there, then it will affect the quality of your output. So how is your muck file, whether it is good, bad, poor, and most important design parameter is your fragmentation is one of the most important design parameter. Now here in the diagram, start from your ore body, it may be limestone or coal. So these are the subsystem involved in this: drilling, blasting, loading, hauling. Then there will be primary and secondary crushing. So fragmentation often in the blasting process influences the downstream cost like loading, transportation, processing. Everybody knows this. Fragment size should be suitable for further handling and processing equipment to be reduce the total production cost. So ultimately, we have come to the conclusion that this fragmentation size is very important in the cost because cost and economics is involved. Now, there are so many methods for mean fragment size assessment, like one of the latest method nowadays we are using, that is digital image analysis technique. It is having the advantage like the method is precise and fast, easy to use, and how we are taking the samples or the images in between the mucking, loading. So at least we need more than 15 images. There should be good illumination. But nowadays we have started this drone technology. I'm also procuring one drone with the latest laser technology. So there is no need of going physically there in the muck pile because it involves lot of time and all those things. This Spragle is developed by our Simper only. So these are. So what are the specialists of this Spragle is because it is indigenous. It is developed by our scientists only. So in the best capability of this Spragle software that we can measure in situ block size also as well as the blasted block size also. These are the systems involved in this. These are the stages involved while doing this software mean fragment size analysis. So these are some methods available for this mean size fragment oscillation, like visual estimation, then sieve analysis, physical measurement, empirical method. Now coming to the empirical method, I have in this paper only I have developed one empirical formula, so that if you know the specific charge, we can directly predict the mean fragment size that I'm going to tell you. So, so one of the case study we have carried out in the ACC, the production capacity of that mine is 1 million ton per annum, and the project area is 53.57 hectares. So height of the bench is around 6 to 8 meter, and the width is around 15 meter. So beside diagram, we can see this Google diagram. Now, so generally we are doing the joint mapping of this phase. We are where the vertical joints are there, oblique joints are there. So we are measuring the spacing, persistence, and after doing the blasting, whatever the muck pile is getting, that is the mean fragment size we have to calculate. Now directly I will come to the point, that is result. So whatever the case studies I have carried out with the number of blasts were 14. So in this mean in situ block size and the mean fragment size, left hand this y-axis and x-axis, we can see there is very good correlation we can see. So, so we can come to a conclusion that there is a basic premises and confirm that there is relation between blasted block size and in situ block size. So in situ block size is nothing but the naturally available blocks in the bench. Some linear regression analysis I have carried out. While explaining, these are the blasting parameter like burden versus mean fragment size. It is going very moderately. Spacing is also going very moderately. Stemming is also going very moderately. In situ block size and mean fragment size is also going very moderately. But in the case of this specific charge, increasing. In the case of this energy utilization, it is also going. Your BBS and IBS ratio versus this energy utilization, they are going in the opposite direction. Now, the surface response surface model I have carried out, and see in this 3D surface, whatever I explained in that earlier this graph, here you can see in the 3D model you can see specific charge. This is a hard rock and this is a soft rock. In that mines, it was a hard rock also and soft rock also. So you can 3D, you can visualize how they are behaving. The specific charge, how it is behaving with your mean fragment size. So basis on this multivariable analysis, that is ANOVA, I have developed this equation. Here in this equation, hard rock and soft rock, one factor is there 1.8, and with the respect to the specific charge, that is 1.5 Q, And your, if you know this, if you have carried out this mapping, and if you know the mean in situ block size, so you can get, by not measuring this, you can predict the in situ block size directly. So you can, this is the one of the latest I am trying to develop it, and it is the part of my doctoral thesis also. So soft rock also, there is one factor, and there is specific charge. If you, what is there, you can, there is, if you can predict, then there is no need of measurement. You will not go measurement again. So if you can predict something like, if you can predict the mean mean fragment size, so directly you can put, if you know the Q is nothing but the Bernoulli spacing and charge per volume, if you know, so you can directly predict, and this correlation is also coming around 95. So this study is limited to only ACC mice. I am trying to get so many data, so can I develop a model for prediction the mean fragment size. We are using the Kujra model that is developed in 1973. Now a lot of technology has developed. So this is one of the model I am trying to develop. Already I developed, but I wanted to make it a universal model. So, so whatever I told, it is shown here. Variables like burden, spacing, stemming, how they are behaving, and what is the role of rock strength. So I wanted to, in the conclusion, now I wanted to tell you that this drone technology is very much important, and with the help of drone and with the laser technology, we can easily find out, we can easily measure the fragmentation. And with a new, developed model, if you know the specific charge, we can also predict the mean fragment size. Thank you very much. Thank you very much. Thank you, sir.
Actually, thanks to IBM for making drone a essential requirement for all metalliferous mines. आज से 5 साल पहले थाईलैंड का एक क्वेरी में हम लोग गए थे, वहाँ पर ड्रोन को देखा, वहाँ कोई ब्लास्टिंग गार्ड नहीं होता है. Their boss sitting in Bangkok, and the mine is almost 450 kilometers from Bangkok. वो बॉस अपना मोबाइल में देख रहा है कौन आदमी 500 मीटर ब्रेक करके अंदर घुस रहा है, ओनली थ्रू दी ड्रोन. वो हम लोग का सपना था 6 साल पहले. एंड टुडे आई थिंक एवरी माइन इज एक्सपोज टू यूज ऑफ ड्रोन्स. एंड सांगोडे जी, आपको रिक्वेस्ट करता हूँ, योर नेक्स्ट पेपर शुड बी नॉट ऑन कजरम फजरम. उस कजरम वगैरह पुराना हो गया, बासी हो गया, उसको हटाओ, आप ड्रोन का साथ इंटीग्रेट करो. और फर्दर एक काम करना पड़ा, बॉल्स खरीदो. वहाँ पर बैंकॉक में क्या कहता, थाईलैंड में दे यूज लॉट ऑफ बॉल्स. जो आपका फीड साइज है क्रशर का, उस साइज से थोड़ा स्लाइटली बड़ा वाला बॉल्स क्रिएट किए थे. हर ब्लास्ट में 5-10 बॉल फेंक देते थे. वो ड्रोन उसका कैप्चर करता था इमेज, वो डिस्ट्रीब्यूशन कहाँ कहाँ है, वो बोल्डर से वो बताता था. उस डायरेक्शन में बात करो. कजरम में थोड़ा मैथमेटिक्स ज़्यादा है, एंड माइनिंग वाले मैथमेटिक्स देखने से थोड़ा डर जाते हैं. वो डराओ मत, आप थोड़ा ड्रोन को प्रैक्टिकल एप्लीकेबिलिटी करो. नाइस सेशन, आई थिंक. ओके, नाउ इट इज ओपन फॉर द क्वेश्चन आंसर्स. ओवर टू दी आवर डिस्टिंग्विश्ड पर्सनालिटी सिटिंग ओवर हियर. फॉर द फर्स्ट पेपर, प्लीज पुट योर क्वेश्चंस.
This is for the presentation on the HBGR by Mr. Janardhan. So I am from MSPL, director. I was wondering, when HBGR can be useful on a conventional ball mill, why you suggested us to go for ball mill, the plant which is under construction now in Sandor?
Sir, HPGR is before the ball mill. Ball mill is doing the finish grinding, and HPGR is doing the maximum work so that the power consumption in the ball mill is reduced. And FL Smith, after acquiring ThyssenKrupp Mining in 2022, we started.
I'm talking very recent. Under your, this one, FLS Smith recommended ball mill. or the HBR, which I was actually pleading for HBR, saying that it is not economical. I don't know, your team from Chennai or somewhere came and taken the order and were implementing your circuit in Sandor plant, beneficent plant. But whereas you are, advocating the HBR is a better cost reduction, whatever it is. But the other way, the team was pleading for the ball mill.
Sir, sir, to be frankly saying, FL Smith acquired ThyssenKrupp Mining, and the transition happened almost for more than 1 year, 2 years.
But your order must be very recent,
Maybe
recent
two.
months, not yet.
Sir, HPGR is not eliminating the ball mill.
No, final stage you have to go to ball mill.
Yes.
I do agree. Now up to 3 mm size reduction, we can always recommend HBR.
Exactly.
But
Instead
why
of
you
tertiary-
people have, advocated and we already gone for the circuit? Just...
No, sir, HPGR can be put after the tertiary crusher also on a quaternary stage for further size reduction and...
See, the reason why HBR I wanted, during my research on waste management, I also studied HBR in a school of mines. From that time, I became I'm fascinated with HBR. So I want to introduce in MSPL HBR, but none of you people are recommending the HBR. That is what my issue. You can go back and see why FL Smith is asked for the ball mill.
I can answer for him. The answer is that you find out what is the relationship of the compressive strength or bond index with the system.
No, Saab, it is not like that.
If it is a softer material with low bond work index, probably the addition of HPGR as a very high expensive equipment may not get translated into the benefits what your exact ore need to get.
आप एक काम करो, when you go back, HPGR आप हो, ball mill वाला है, दोनों को लेके साहब का पास आओ.
Competition with other person. So the cost was more. To reduce that to, compete with other competitor, you gone for ball mill. That is my feeling. You go back and study.
Yeah, we will
you ask your
review it,
colleagues
sir.
why you have been advocating for the ball mill for our purpose.
No, if apple to apple comparisons are being made, we would have definitely promoted. But I was not there then.
You are not there.
Yeah.
But I want that answer. Whether I'll give my mobile number, just
Sure, sir.
talk to me. Okay?
Thank you very much. I think ये सेनोय साहब आपको भी HPGR चाहिए क्या? Because you are having one of the best process in copper. Over to the next author. Thank you very much.
Thank you.
Next author. No author? No questions? Somebody think?
Yes, sir.
कुछ लोगों को बोलो क्वेश्चन पहले से तैयार करके आपको पूछेगा. पार्लियामेंट में नहीं होता क्या क्वेश्चन पहले से दे दो फिर आंसर देगा मंत्री जी. आप वैसे कराओ नेक्स्ट सेमिनार में.
So shall we move forward if there are no
Yeah,
questions?
yeah. Over to my colleague. He will brief the session. Please.
Good morning, sir. Respected Sri Pankaj Koshe Sahab, Kale Sahab, Naniwal Sahab, Gujar Sahab, Dikari Sahab, Kunaram Sahab, Kaiya Sir, Gurdeep Singh Sir, all the eminent personality present over here. This session was having basically 4 papers. The first was on HPGR, high pressure grinding. Thanks for giving us a new method and machinery which consumes less energy. 2 papers was again concerning with the space mining technology and transforming mineral waste into sustainable nanomaterials. This was a very good ideas presented by research scholars, Space mining really needs another deep dive. We need a lot of things to explore in this subject, as well as transforming mineral and transforming mining waste in waste to wealth. A lot of people are doing work in this field, making railway ballast, sand, making tiles, recovering rare earth minerals. A lot of things are going out. Still, we need a lot of things to be derived out of this subject. And the fourth paper was regarding the blast fragmentation given by Sangode sir. Thanks for giving empirical method with the specific charge. And obviously, we need to hear it from a specialist of blasting who is present over here, Mr. Pradhan. Thank you, sir. This was all about this session. I hope you get insight over all these subjects, and I must congratulate to the presenters. Very well presented the papers over here, and thank you, sir.
Thank you. I request the audience to give a big hand for the youngsters presenting 2 papers. And also, Kale Saab deserves the thanks because he only must have maneuvered them to make papers. Kale Saab, agle semester. देखिए मेरे अगर बोलना शुरू करूँगा तो यहाँ खाली हो जाएगा. So I am very much scared of speaking much. My only request, the best thing of this session is 2 newcomers have come. As said, my first paper I made presentation in the year 1981 in Jodhpur, when MBM college organized a seminar on drilling blasting. That was a huge gathering. Bhandari साहब नए ideal से join किए थे when I was a student. So उनका आदेश था, निर्देश था कि you have to make a paper. मैं बोला मेरे को आता वाता कुछ नहीं. बोला नहीं, जितना आता उतना बोलो. I was in Bokaro steel plant. So I remember Bhandari साहब has pushed me into the dais. और मैं जितना पढ़ के वो जो आज को ट्रांसपेरेंट सीट में लिखते थे हम लोग पढ़ूंगा. So I still remember, but today is the digital intervention years. They made beautiful slides. I wish more number of papers from the youngsters should come. We have to be on this. जो 1990s में उन्होंने think किया था, आज paper में आया. There is a paper from the youngsters. With these words, we conclude this session. Over to the organizers.
Thank you, sir. Thank you so much. To acknowledge the invaluable contributions of our speakers, I request Dr. G.K. Pradhan and Shri Rajesh Bhattacharya to kindly step forward and present memento to our speakers. I invite on stage Mr. A. Janardhanan, Mr. A. Janardhanan. We'll invite Ms. Daksha Vyas and Ms. Ruth. Mr. Kaustubh Deshpande. May I please call upon stage Mr. Anand G. Sangode. Our heartfelt thanks to Dr. G.K. Pradhan and Shri Rajesh Bhattacharya for steering the session with such insight and grace. I now invite Mr. B.L. Gujjar, Controller of Mines, Indian Bureau of Mines, to kindly felicitate them with a memento as a mark of our appreciation and respect. Ladies and gentlemen, please give a big hand for Dr. G.K. Pradhan and Mr. Rajesh Bhattacharya. Let's take a quick breather. We'll take a short tea break, and may I request everyone to please reassemble in half an hour. Thank you. We are ready to reconvene. I request you to please take your seats. Ladies and gentlemen, please settle down. We are ready to start with our next session. The next session turns the spotlight on one of the most urgent imperatives of our time: sustainable mining. In a world increasingly mindful of environmental impact, this session examines best practices in controlled blasting, land reclamation, and safe use of explosives, ensuring mining doesn't just extract, but also nurtures. Let us begin this vital session. The session will be chaired by Dr. Shrikant Anavarapu, former professor, IIT Kharagpur, and Dr. Sanjay Sarkar, DGM MOIL. I request you to kindly join us on stage, please.
Thank you.
Thank you, sir.
Good afternoon, everyone. And everyone getting ready for the second session, after which we'll have the lunch break. So I know that towards the end of the session, everybody will start, wanting to rush towards the lunch. So I'm taking the opportunity to say a few words about the importance of this session. I don't know how many of you are aware, but our Minister of Mines and Coal, Shri Kishan Reddy ji, he is very focused on two things in mining. And those two things are reclamation and community development, which are very, very noble things. But it's something that we have always been doing. But with the focus on this, what we'll have to do is to do it better. And I know that the deliberations and the discussions that we're going to have here will help us increase our focus on these two aspects. And just like Lloyds Metals have done in Surjagarh, similar success stories will develop around the country. There are, and this is going to come down, I know it's going to come down as guidelines, frameworks and guidelines. And it's already happened in coal. They have a framework called Reclaim, which was developed by the Coal Controllers Organization. And as I kuch metal mines maybe aane wala hai, we just have to be prepared, ready, and make sure that whatever we are doing fits into that framework and goes beyond that framework. Okay? So just wanted to give this little bit of brief introduction before we started, so that I get a chance to speak before all of you run off for lunch. Thank you very much. Can we invite the first speaker, please?
I invite the first speaker, Dr. Gurdeep Singh, to kindly present on sustainable mining development with best management practices.
Right. Hello. Maximum maximum. Maximize कर दो.
प्रेजेंटर व्यू को बंद करो तो आ जाएगा ठीक है हाँ it's okay
Okay. Yeah. Well, good morning to you all. I'm sorry for the mess up to start with. Anyway, we all talk about the sustainable mining. There are many controversial mines where a lot of money has been spent. Government of India's flagship mines were also there, but they could not start because the sustainability was not there, and we did not care for the various issues, particularly the environmental clearance and related issues. They are very, very important. This is another thing. So a number of bans have been imposed. Karnataka, Goa, Odisha, Jharkhand, and it's still going on. A number of studies have been carried out. So I was involved in carrying out the study on the sustainable mining for the Goa. Then Supreme Court Empowerment Committee is there. So they made the R&R plans in the mining region to start with. So this is important reclamation and rehabilitation plan and supplementary environmental safeguard plans. Dr. Meda Venkataya, he was deeply involved in the Bellary Hospital in Sandur, and I got the opportunity to visit that time and learn good things from him. Anyway, in the sustainable mining, as per the Supreme Court, the feasible production capacity is the first factor to comply with. So we should not produce the material as per the statutory provisions. First is the production capacity allowed as per the IBM, MOEF, or Pollution Control Board's statutory approvals. They are the must. I think people did not care for that. And that is the result. And they had paid huge fines. Then production capacity based on the available mineral reserves. So when we presented to the Supreme Court of India, so Justice Patnaik bench, they asked the first question to us, what do you mean by sustainability? So we gave the, basis on which we worked out the sustainability, and they say, no, you are wrong. It's not on the 15-year basis. It should be counted on the 30-year generation basis, and minimum 3 generation resources you need to work out. And in the case of this, I think you may have, in the case of the coal, situation is other way around, okay? Because the incubation factor and number of other things, they come there. Then production capacity based on the available dumping space. A lot of violation took place in this, particularly entire Goa. They have the 100-hectare restricted mining leases. So they do not have the capacity to contain that. And there are a number of places in Jharkhand, Chhattisgarh, and other states also, same thing happened. Okay? And then production capacity based on the capacity of transport infrastructure based on the standard prescribed by the Indian Road Congress. So we have not been carrying out. Lloyd just made a very good presentation. The transportation has a direct impact on the climate change. So you need to, have some provisions that you have the environmental friendly transportation, and particularly whenever we have the surface transportation, it must meet the Indian Road Congress guidelines. Then available mineral resources, existing mineral reserves and the resources based on reliable existing exploration data approved as per IBM are considered for computing the production level, taking 20 years life of the reserves, okay? And in the case of Goa, they made it 30 years. Then this is mainly to discourage excess production if the reserves do not support, aimed at encouraging exploration. Then production capacity based on available dumping space. Dumping is not allowed to be carried out outside the lease area, okay? And number of mines have been shut down, and you know, they have to face number of consequences as a result of that. Then dumper capacity is computed based on the area volume identified for bed dumping as per IBM approval mine plan. Ore production capacity is computed for 5-year period based on the actual stripping ratio of last 5 years. Dumping volume is computed based on scientific dump planning, terrace dumping, incorporation of drains, toe walls, check dams to ensure stable dumps. This is basically to ensure stable dumps and to encourage backfilling, leading to improved mine land reclamation. I think there is a paper following me on the land reclamation also. Here the important thing in the sustainable mining is you must ensure the physical reclamation prior to the biological reclamation or whatever reclamation you want to go. Okay, this is on the transport infrastructure. So adverse impacts of mining actually relate to traffic related impacts. See, while I was carrying out the study, so Goa people, you know, the entire, generally all people opposed me. They say you are the agent of the government or you have become agent of these mining companies. I say, whatever way you perceive, I'm here because of them. They, you know, damage our equipment and they did not let us carry out the study. Then we carried out a workshop with the people there. Then, you know, number of, you know, views came up. The people were very angry because of the transport, particularly in Goa. There used to be around 4,000 dumpers, which enhanced to 25,000. And the production capacity from mere 20 million ton, it has gone to 54 million tons. And that was the root cause. And you know, people, they went to High Court, then finally they reached the environmental friendly transport systems. And in EC conditions also, number of provisions have been provided. And whenever you go and seek the TOR and followed by the EC, the conditions are there. So people get happy that we got the TOR and we got the EC. But you know, where is the compliance? Okay? So they say, somewhere, you know, they say you should use electrically equipped equipment. Okay? And then they realize, okay, what condition it's so expensive, will not be able to use that. Then LNG waste and number of, you know, other conditions they have imposed, and they say if you are not able to do that, then do by the railway. Okay. So anyway, the transport route for carrying out the in any case, if the nothing is available, so you need to follow the Indian Road Congress, and quality of roads, terrain, type of traffic, other public traffic plying on the same road are other factors considered while computing the mine capacity. Okay, and this is to encourage transport options like aerial roadways, downhill conveyors, rail transport, which are coming in a big way. Okay, see, this is sort of a Goa case. The basic thing Supreme Court was perturbed about the complaints of the public. They say Goa is a very peaceful state and they are disturbed in a big way. So I think we cannot allow the mining there. So we propose the capping there. Capping, as they have the 17 routes of the transportation. So as per Indian Road Congress, we worked out the prevailing setup and how it should be guided. So, and then accordingly, the capping was proposed each route wise. So there are the different scenarios which become the bottlenecks, and we say this road is very wide, and when we are not computing that. So all the 4 scenarios we need to consider while computing the capacity of the road to carry out the transportation activities. So we did each roadway wise, and this is the sort of traffic monitoring data which shows the baseline scenario and the mining scenario is quite different and it's not permitting. And when we computed the transportation capacity each route wise, so these were the several routes were there. So we are not able to go beyond this 5.785 on the Adwa Valley and Bicholim, like that. So it was coming to around 25 million tons. Then when we presented the Supreme Court, so Supreme Court says that let us get it, scrutinized by another committee. Then other people sat with us. They say, why don't you come down to 15? I said, there should be some logic. So this is a scientific basis on which we have computed this. So then they say, no, Honorable Supreme Court had asked and we need to do something on this. So they brought it down to 20 million tons. Then, this is what the observed concentration levels with ongoing mining activities. That time, we computed the SPM also. SPM has been taken out. PM10 and PM2.5 is there. So you must be seeing the scenario, how the, concentration levels were there, and predicted concentration level with transportation cap, how the levels have been falling. And this is the National Ambient Air Quality Indexing System. We used it on the basis of the Air Canada and the US EPA. And National Air Quality Index system followed after this when we make the presentation at 3 places, Supreme Court, MOEFCC, and the CPCB. So color coding system has come. So if you observe this, so still this is not acceptable. But they say that you cannot do that because the sizable population is dependent upon the mining activities. And their GDP, the major part is coming from the mining. So at one time, Supreme Court told, why to have mining in Goa? So let us go away from that. And it is, not that important, and the reserves are not that to level. And India has already got so much iron ore reserves, and that too with other grade. So then, social and economic factors are presented to them. So then they agreed, okay, with this condition, we'll be able to do that. And when we are digging out the things, people have already done the work there. And there's nothing great we have done there. So, already the government of Goa and Indian government have got number of schemes working out for the different systems. And this system is already there, bypass Kurchoram town and the Kurchoram Tilamol road. So they have the dedicated transport corridor systems. So Mr. Manohar Parrikar was then Chief Minister. So he also guided us, okay, this is the way. Then they say that we'll be starting this, but it has not come up till today. So anyway, I can skip these. Then, there are different transport systems which I was talking about. This is the story of the Tamnar. Tamnar is in the Raigad, and this is around 16 kilometers from the mines to the power plant. And down under you have the river, you have the villages, you have the agriculture activities, you have the forest land. And absolutely there is no complaint. When the people were flying on the main road, lot of noise, vibrations, and lot of, wastage and losses. This way, things have become very environmental friendly, and people are happy, the project proponents are happy. This is another view, and this is another view. And similarly, this is the NMDC is another very good example. Hindalco, there in the Lohadarga, they also have a very good system. Similarly, in Torongolu, Bellary Hospital, GSW presented to us that they have 24-kilometer conveying system, which they are extending to 36 kilometer. And they say that problems are not there, so we have to yet to study that. So this is the, another environmental sustainable transportation at NMDC. So this is what the Lloyd presented. I'm just, replicating the same thing in the case of the different. Dabuna is in Odisha. Mr. Sabdal Sachi Mohanty, he was working there. It is so good. They presented to our EAC, so people appreciated it. And this becomes sort of a EC condition in many other projects to follow with. See, this is another thing, routing Odisha, Chhattisgarh and AP. So you have the water pipeline, you have the slurry pipeline, and you have the ghat section, and you have the different type of the system, and it is very environmental friendly and very energy efficient. So then comes the, basic sustainability things, that we need to have the different engineering structures in order to control the erosion and the related sedimentation aspects. This is another one. You have the settling ponds, you have the dirty water and coming out clearly. So there are number of systems are there. The local waste materials are used as the filters, and people there used to complain, particularly, you may be knowing, on the foothills there are the agriculture fields, and lot of agriculture activities were hampered because of the mining activities. So right now, the mining people, they are providing them the treated water, and which is working sort of a type of the low fertilizer also for their agriculture fields, and people welcome there. See, this is a system, we developed by working with them. They used to have the very high rush of the turbid water with the, TSS. So this zigzag bunds were there. So we are providing the more retention time so that people are able to get the clarified water. Otherwise, there will be visual pollution. People will not be able to perceive. This is another system of the recharging. They are the air quality management system. No, water systems have come up. CMPDI has also come up a very good design. So they have the shelter beams and different type of the sheets they have able to develop, and so that they can obstruct the wind-based erosion dust. So these are the erosion control systems. They started with a number of things, the coir mats, jute mats, and number of, see, this has become a EC condition. See, it is there all over. You can have another view. Just see, Dr. Meda Venkataya gave me the opportunity to move around his area, and I could visit, all the 3 areas there. Just see, so nicely, toe wall with nice drainage system has been developed in a dump. Greenery has come up there. Just see this is a GeoGreen blanket, which has become now quite commercialized. This is sort of a Goa scenario where the mining has been done up, so no cash crops are being taken place from this. So this is another thing which came out by the Jindal JSPL in Angul. So a lot of protests were there when they were cutting the trees. So in India, Mrs. Indira Gandhi brought the first transplantation scheme during Asiad 1982. Around 15 lakh trees were transplanted along the ring roads and the other areas. And gradually it followed, but the transplanter is costing too high. It used to cost 2.5 crore. No, the value has come up, 1 crore. So this is being used, and many people have got their local technologies. So just see, it's totally uprooted, एंड जैसे हम लोगों को फ्रैक्चर हो जाता ना, तो ये पेड़ों के साथ भी उनको सीधा करके प्रॉपर न्यूट्रिशन दे के mulching and all other stabilizers are being put, and this is the way it is being put, and the success rate is very good. This is another practice you may be knowing, Gujarat Mineral Development Corporation. So I worked there for 3 years. So number of good things happened. I was very happy. Say you have all the wildlife and related ecosystem has developed so nicely. People are going for picnic in the mines. Just see, this is another good view. And the renewable power. So all their energy needs are being met by particularly the office systems. They have minimum 240 kilowatt at the office system, and they have generated around 250 megawatt on the windmill, and this is the Panandro one, they have got 10 megawatt. Anyway, this is the climate change is coming a big way, and it has been made mandatory in many mining companies. Only EVs has to be used, and other fleet has been substituted with the EVs.
May I request you to just wind up, please? Thank you very much.
I'll just do that. I'll do that. This is about the sustainability. There are 7 components in this. So maybe I will discuss later on. I'll just give the examples. This is the sustainability examples. This is the Blue Circle mines of the Australia, limestone mines. They work with the community and exhausted all the mineral resources, and they gave the caves, and it's sort of a very good, touristic place there. This is another, we have to pay to get in the entry, and FM radio is also there. Anyway, you can see the, views. I'm sorry I exceeded the time. This is another, a lead zinc mine. They do not have any backfill material. So they got the Sydney's garbage coming there, and they have 3 bioreactors there, and they generate 30 megawatt power there. This is, okay, I'm just closing it. They are the scenario before and after. And this is sort of the very good, this we did it in Jharia coalfield. The mine water we treated, and my PhD thesis was on mine water augmentation for drinking purpose. In 1983 I completed, and it became part of the national water policy, and all the, particularly the coal mining areas, they have been augmenting their water for the drinking purpose, and around 40% of the Jharia's demand is coming from the mine water augmentation. Anyway, this has become a tourist place also. Anyway, I'm sorry, So this is another issue which we need to deliberate upon in the case of the sustainability aspect. When you do the mining, what will be after that? So this is being deliberated, and we worked on this, and this is about the Jharia coalfield. Say you are to plant 1 crore trees over 4,500 hectares of closed mining areas. So this need to be done in consultation with the ecological experts, with the local people, and with the government, and this will become a source of the livelihood. This is sort of the Goa case. Football Academy has come up on the Mindland. It is of Olympic standards.
Last slide,
okay.
Please. Okay, thank you.
This is the Panch Amrita, declared by our Prime Minister Modi at the Glasgow COP26. So which we are working out. The very good news is, day 4 yesterday, we have exceeded the target of renewable energy of more than 50%, okay, which we were to achieve in 2030. And many more companies and entrepreneurs, they have also done that. So thank you so much. I was with the Supreme Court committee, so we got the Panna mine reopened. So thank you so much.
Thank you so much, Dr. Gurdeep Singh. It's really wonderful to see so much work being done in sustainability. Just like I said, this is going to come as a requirement for all of us. Couple of questions for Dr. Gurdeep Singh, if anybody wants to ask a couple of questions.
So, shall we take it at the end of the session?
Any questions for Dr. Gurdeep Singh? Yes, right in front here. Can we have a mic for him, please?
Road capacity, right? So that time I was posted in Bangalore. So I come across where one of the criteria has failed. One mine having totally mineralized area. So the ICFRE prepared the mining plan, R&R plan. So they mentioned there is a zero dumping capacity. So the annual capacity of mine plan will be 0, which was totally hypothetical. Being entire mining lease area mineralized, it is not a curse, it is a boon. And there are planning, you can make half of the lease area for temporary dumping, you can work in the half of the area up to ultimate pit limit, then we can do vice versa. So in that way, that criteria, I find it was a hypothetical.
Thank you very much. Any other question? One more? Yes, right in the back there.
Good morning, sir. So my question to you is that in the slide that you have shown the geotextiling, so what kind of material has been used in the geotextile that you have shown?
Jute is the most acceptable, and there is a biodegradability test you need to carry out. Okay? Okay. This requires screening by the...
Okay, thanks.
Okay. Thank you very much. I know there's one more question. Can we have that during the lunch break? Okay? Thank you so much. Dr. Gurdeep Singh, wonderful presentation. Thank you.
I invite our next speaker, Dr. G.K. Pradhan, to present on safe and sustainable use of explosives.
प्रधान साहब को वेलकम करते हुए मैं रिक्वेस्ट करूंगा कि 15 मिनट का टाइम अधेयर करें. Thank you so much, Dr. Pradhan.
Today we are, good afternoon. Today we are in a place which produces some of the best type of explosive in the country, Nagpur. Solar is a company which was visited by Honorable Prime Minister few months back. It is a global company now. In 80s and 90s and even up to 2000, the Solar owner was a transporter of explosive and a dealer, but today he is a global player in explosives. We are really proud of the city of Orange City of Nagpur to have the basic base of explosives here, with PESO having the regulatory framework and IBM and WCL giving the technological inputs. All these things, see, we have a wonderful tradition in our country. When you visit any of the temples in the country, that shows that how old was our mining. जितना भी टेम्पल जाएंगे आप देखेंगे कितना nicely cut ore pieces are there. That shows that this technique of blasting or technique of rock excavation dates back to even Mohenjo-daro and after. These are the, you see that this is a temple table in the book publication brought out for the seminar, which shows how we are advancing. Because majority of the mines are going deeper and deeper. One of the best cases is Malanskand. Malanskand is one of the deepest metal mine in the country. But see the technology, they have transferred Malanskand into an underground mine, and they have gone for the best of technology in underground. Similarly, in case of coal mining, we are not shifting from open cast to underground. As a result, what happened, any of the mines you visit from Umred to Singrauli or Singrauli to Talcher or Neyveli, you will find the neo forest or hills, newly developed hills. That is primarily because the deeper you go, your stripping ratio increases and the consumption of explosive also increases. Another best part in our country is that we are most up to date in manufacturing of explosives and accessories in the country. The best of explosive, emulsion explosive, is the order of the day. And similarly, we are into the use of digital detonators or electronic delay detonators in our operations. The usage started with one piece costing 1800 rupees. Thanks to Vedantas and Hindustan Zinc, for the first time in the world, they have consumed highest number of electronic detonators in Rampur Agucha. At that time, people were surprised what these people are doing, 1800 rupees per piece of Orica Mac electronic detonator. Why they have used? Because they have to open an underground mine below the open cast mine. And the stability of the host rock, stability of the footwall and hang wall, they predicted and found that with electronic detonators, they can have a better life of the underground mine with a good strata control inside the underground mine, which is almost, I think, 5 million tons of excavation. हम लोग कोयला में 3 मिलियन टन में रह गए झांझरा, और उधर वेदांता हिंदुस्तान जिंक चला गया 7.5 मिलियन टन एसके माइंस. एक्सकवेशन फ्रॉम अंडरग्राउंड, कैन यू इमेजिन? हम सोच नहीं सकते हैं. डेली 50 से कभी कभी 100 टन्स ऑफ एक्सप्लोसिव दे आर ब्लास्टिंग. एर्लियर इट यूज्ड टू बी इन केजीज. हर होल में ग्राम में एक्सप्लोसिव डालते थे. सेना साहब विल एग्री विथ मी इन एंड मोस्ट ऑफ माय फ्रेंड्स इवन इन मॉयल, हम ग्राम में ही रह गए पर होल. And we have crossed much more ahead in Hindustan Zinc. That is because of the transformations we got in initiation technology and explosive technology. Then comes the accidents. बड़ा दुखद स्थिति है. This is the year, in last 12 months we lost almost 12 to 15 lives, in not more than that, 20 lives. In one of the cases, I was involved as a auditor for West Bengal Development Corporation. 9 people died without any blasting. एक्सप्लोसिव अनलोड किया ट्रक से, वो लोग बैठे कुछ करने लगे. 10 मीटर दूर वहाँ पर मैनेजर सब खड़े हैं, मोबाइल में कुछ बात कर रहे हैं. ये 9 आदमी उड़ गए, कन्वर्टेड इनटू पीसेस. No hailstorm, no blasting, no fire, no electricity, nothing. Young blood, बताओ कैसे हुआ भाई? ना आग ना कुछ. Yes. मेटल वाले बहुत लकी हैं. आपका MMR has not been amended and there is no incorporation of restrictions in use of mobiles, smartphones, clothes, etc. blah blah. In mines, but it is available in the circular. 2017 CMR में already it is incorporated under the explosive chapter. You cannot carry any mobile, smartphone, nylon dresses at the place of blasting. वो जो एक्सीडेंट हुआ उसका डेप्थ में व्हेन वी वेंट एंड वी स्टडीड विद सम ग्लोबल स्टैंडर्ड्स, 2.5 मीटर में जितने लोग बैठे थे सब मर गए, और सबका पास स्मार्टफोन था. थैंक्स गॉड इट वाज वेस्ट बंगाल पावर डेवलपमेंट कॉर्पोरेशन. द CMD इज एडिशनल चीफ सेक्रेटरी. दे वांटेड, आई हैड अ फर्स्ट इंटरेक्शन विद, ही टोल्ड अस डोंट माइंड एनीथिंग, आपको जो देखना है जो करना है करो. वो आपका MMR, CMR, PMR वो सब छोड़ो, आप देख के बताओ क्या करना है. व्हाट वेंट रॉन्ग. अरे बारूद यूज करोगे, एक्सप्लोडर लगाओगे तब तो ब्लास्ट होगा. बिना कुछ किए मर गए 8-9 आदमी. ईच वन ऑफ देम हैड ए स्मार्टफोन. द सुपरवाइजर, हम लोग कोल माइनिंग पार्लेंस में बोलते हो फोरमैन, ओवरमैन. His wife was admitted in the morning, early morning, for delivering a baby. Every 10 minutes he was talking to the hospital, knowing what to know, all these things. That fellow was also killed into pieces. जब देखा गया मैनेजर 10 मीटर दूर में खड़ा है, बच गया. When we went into the records, physics of explosive and vibration, we found the impact of any mobile phone is within 2.5 मीटर. इसका मतलब आपने ये मत बोलो प्रधान साहब बोल दिया 2.5 मीटर हम माइंस में कहीं भी यूज करें, प्लीज डोंट यूज. जब मौत आता है वो स्केल लेके नहीं आता है, वो अपना स्केल रखता है, उसका अलग मापजूप होता है. So after that we recommended all the mobile phones, whether with a mechanical engineer, even the general manager or vice president, please keep it in the gate. Strictly it was, they have got 4 coal mines. And after that I had the opportunity to the explosive audit for other Singrauli and other mines. एक्सप्लोसिव वैन का अंदर मोबाइल फोन है, रसोई गैस है. सो मैं सबको रिक्वेस्ट करता हूं भैया दूर रखो ये सबको. एक्सप्लोसिव एक्सीडेंट बड़ा हॉरिफिक हो रहा है आजकल. माइंस में तो हम लोग बहुत कुछ इम्प्लीमेंट करते हैं, बट सच टाइप ऑफ एक्सीडेंट nobody had imagined ever. The another accident in Jindal Power coal mines in Tamnar. ब्लास्टिंग यहाँ हो रहा है. नॉर्मली हम लोगों का बोला जाता है कि सामने नहीं कोई खड़ा होना चाहिए या कोई गाड़ी नहीं होना चाहिए, फायरिंग सामने से नहीं करना चाहिए, सारा पीछे करना चाहिए. 2 यंग माइनिंग इंजीनियर्स कॉर्नर से ब्लास्ट किया, पत्थर गया, दोनों मर गए. उनका कहना था हम तो रोज करते थे. भैया इस सामने मत करो, मत खड़े रहो, कम व्हाट में पीछे रहो ना. इस तरह इतना क्या बोलते हैं अनबिलीवेबल एक्सीडेंट्स हुआ. इसीलिए प्लीज डू सम ऑडिट ऑफ योर एक्सप्लोसिव यूज, बहुत जरूरी है. एक्सप्लोसिव में आजकल एक और आ गया कि थर्ड पार्टी एग्रीमेंट, बारूद कोई और लाएगा, यूज कोई और करेगा, ट्रिगरिंग को और करेगा, माइंस मैनेजर साइन करेगा. दैट एंड्स इट्स रेस्पॉन्सिबिलिटी. नो सॉरी, सबको ध्यान में लेना पड़ेगा. ईच वन ऑफ देम आर अकाउंटेबल. So these are some of the statistical things in the book. These are the trend of accident. We are lucky we have got all varieties of explosive. हमारे metal mine, Ultratech and other companies, they are doing wonderful job as far as N4 use concerned. 35% of fuel, that is diesel oil, was replaced by used filtered mobile or what is called engine oils. Excellent result that it has given. Filtered, because आप लोग EIA में कंडीशन है how to dispose of engine oil, used engine oil, वो प्रॉब्लम ही सॉल्व हो गया. फिल्टर करो, यूज करो, ब्लास्टिंग में खत्म. एंड PESO has also given approval. This Deepak Fertilizer, they have got a system of cleaning the material, use mobile oil or engine oil or lubricant, and that can be used as a fuel for your N4. There are other means of reducing the density of N4 by using rice husk, sawdust. 25-30% तक लोगों ने यूज किया. बहुत काम किया, इंडिया में बहुत काम हुआ है, बहुत. एंड वी आर लकी, हमारे यहाँ बारूद हम स्पेरिंगली यूज कर सकते. दीज डेज आई एम हैविंग ए प्रोजेक्ट इन दुबई, इन फुजिरा. वहाँ उल्टा है, वहाँ फ्रैगमेंटेशन नहीं करना है. वी हैव टू जनरेट मोर ऑफ लम्प्स so that those lumps can be supplied to Indian steel industry, because Indian steel industry has certain size specification feeding the SMS grade limestone into the blast furnace or sintering plant or BF. So उसमें हम लोग अभी काम कर रहे हैं. वहाँ उल्टा है, अभी आपका फ्रैगमेंटेशन बोल्डर कम करने के लिए ये उल्टा. So there we try to use as many as initiation system so that we can improve upon the recovery of lumps. क्योंकि lump का cost is almost 10 to 20 times than that of the fines as far as limestone is concerned. In many other ores also you must be having, the cost of lumps are much more higher than the fines. So मेरा कहने का है, and here in India we have the liberty to use any type of explosive anywhere and any type of detonators. In Dubai में वो नहीं है, पुलिस लेकर आता है, हम वहाँ पर 15 ब्लास्ट इवेल्यूट कर रहे हैं, I have not seen the explosive. पुलिस आएगा with all convoy, डालेगा जाएगा, उसके बाद पोस्ट ब्लास्ट एनालिसिस हम करते हैं. But we are really lucky in India. You've got all the facility to measure, monitor, select explosive of your needs. This is another interesting. One of the best bauxite mine in the world is in India. That is Utkal Alumina, नैनीवाल साहब का एरिया में है. Beautiful mine. I am telling you, ऐसे bauxite mine तो कोई वर्ल्ड में सोच नहीं सकता है. नालको था, वो सरकारी तंत्र में फंस गया. And both the mines I have seen since their inception, जब से वो स्टार्ट हुआ दोनों माइन, वो 84 में स्टार्ट हुआ नालको, ये स्टार्ट हुआ 2013. In both the mines I was involved. But Utkal Alumina में they have introduced almost all the latest techniques and technologies of the world. Last month, myself and Dr. B.K. Misra, our HOD, AKS University, we went there. They have got drones, they have got in-house, not hired. They have got scanner. स्कैनर में कोल इंडस्ट्री में क्या करता है, स्कैनर को लेके जाता घूमता है, सर्वे रहा हूं यूं करके. यहां पर क्या किया, they have got a fitting on the top of their jeep, mounted the scanner, it goes round every day, and within half an hour you get the latest, where your benches are, how they are, what volume, what inclines, everything. यहां तक चला गया. They have got the latest of testing explosive. Coal India हजारों लाखों टन यूज करता है, कोई टेस्टिंग वेस्टिंग नहीं है. वो बारूद आ गया, यूज कर दिया. These people have got this instrument. I will show you the instrument. This is an Australian make instrument. नॉन एक्सप्लोसिव कंपोजिशन ले लीजिए, थोड़ा सा 5 ग्राम डाल दीजिए, 2 घंटे के अंदर आपको दिखा देगा इसका जन्मपत्री कुंडली क्या है, कितना ऑक्सीडाइजर है, कितना फ्यूल है, कितना पानी है, कितना एनर्जी, एवरीथिंग इट गिव्स. वन ब्यूटिफुल मशीन आई एम टेलिंग यू. वेरेवर यू आर यूजिंग बल्क एसएमई, बारूद वाले बहुत चालू है, क्योंकि मैं भी उसी खानदान से आया हूं, बारूद खानदान से. पैसा बचाना हमारा सरकारी संस्था रहते हुए भी हमारा एम रहता है कैसे 2 पैसा बचाएंगे. ज्यादा हम नहीं बचा सकते, हमारा ऊपर सीएजी बीएजी सब है. प्राइवेट वाला तो स्पेरिंगली दे रिड्यूस द क्वालिटी ऑफ एक्सप्लोसिव, वो अपने आप एक्सपर्ट बन जाते हैं. होल वर्ल्ड में 4 बारूद कंपनी में, इंडिया में 60 कंपनी है. तो दो मेजर यूजर ऑफ एक्सप्लोसिव्स इन बल्क सेक्टर, प्लीज 8-10 लाख का ये इंस्ट्रूमेंट है. 5 ग्राम लीजिए, नॉन एक्सप्लोसिव मटेरियल रख दीजिए, वो आपको विद इन 2 आवर्स इट विल गिव एवरीथिंग. जब वहां क्योंकि उत्कल एल्यूमिना में प्रॉब्लम किया, इट इज सराउंडेड बाय 2 डिस्ट्रिक्ट, इट इज स्प्लिट बिटवीन 2 डिस्ट्रिक्ट, कालाहांडी एंड रायगढ़, एंड वहां पर फुल ऑफ नक्सलाइट, इट इज ए नक्सलाइट बेल्ट. वहां एक्सप्लोसिव आता है, यूज होता है, खाली होता है, बहन चला जाता है. 2013 से आई एम एसोसिएटेड विद देम, एंड आज तक कभी कोई गलत इंसिडेंट नहीं हुआ, बिकॉज दे हैव अपग्रेडेड देयर टेक्नोलॉजी. दे डोंट हैव एक्सप्लोसिव मैगजीन, एंड एवरी टाइम दे ब्लास्ट 500 होल्स, 8 मीटर बेंचेस, 30 to 40 टन्स ऑफ बल्क एसएमई. ये टेक्नोलॉजिकल एडवांसमेंट लिया, एंड दैट माइन आप विजिट करिए, वर्ल्ड का ऑल स्पेसीज यू विल फाइंड देयर, क्योंकि 3000 फीट ऊपर में माइन है ईस्ट कोस्ट बॉक्साइट में. रेड मड, थैंक्स टू IBM, दे हैव गिवन देम द ट्रायल परमिशन टू डंप रेड मड इनसाइड द माइंड आउट एरियाज. सारा एक्सपेरिमेंट कर रहे हैं. रेड मड को दे आर सप्लाइंग टू सीमेंट इंडस्ट्री. तो आप लोग को मौका मिले प्लीज जाइए वहाँ, हिंडाल्को का है उत्कल एल्यूमिना, ब्यूटीफुल माइन, सोच नहीं सकते इसे भी माइन बनता है। अभी आवर यूनिवर्सिटी हैज बीन गिवन टू एन असाइनमेंट टू स्टडी दी रिफ्रैक्शन स्टडी सो दैट दे वांट टू गेट रिड ऑफ ब्लास्टिंग। वहाँ पर एक एंशिएंट केव है, साल में एक ही दिन ब्लास्ट वो पूजा होता है 14th मकर संक्रांति का दिन, उसको बचाने के लिए दैट असाइनमेंट वाज गिवन टू अस। हमने बहुत सजेशन दिया, दे फॉलोड इट, बट अभी माइन 700 मीटर का तब जब आ गया स्टॉप फॉर एवर, नो ब्लास्टिंग। अभी हम लोगों को अराउंड 3000 मीटर का जियोफिजिकल स्टडी हम लोग यूनिवर्सिटी की तरफ से करने जा रहे हैं, सो एज टू एडवाइज देम व्हाट टाइप ऑफ रिपर दे हैव टू यूज, बिकॉज उनका क्या है, बॉटम बॉक्साइट इज वेरी सॉफ्ट बट टॉप बॉक्साइट इज ऑलमोस्ट 150 मेगापास्कल्स, वेरी हार्ड बिकॉज इट इज लैटराइटिक। तो ये सब डेवलपमेंट हो रहा है, कहीं ब्लास्टिंग में इंप्रूव कराओ या कहीं ब्लास्टिंग से भाग जाओ दूर। कोल इंडिया हैज डन ए वंडरफुल जॉब बाय removing blasting from almost from the coal excavation. They have all gone for surface miners. We have got the largest fleet of more than 400 surface miners in the world, in India. Although it is a German machine, and L&T has come up with an indigenous surface miner. It is also used in African countries. So काफी काम हो रहा है excavation पे. This is one of my pet subjects, thanks to IBM, and in one of their recommendations, they recommended to the ministry for giving me Geoscience Award based on this work, using all empty bottles. जितना बॉटल है बारूद में साथ डाल दो, पैसा बचेगा, प्लास्टिक आपको न्यूसेंस से बचा देगा। ये जब यूज हुआ टाटा स्टील के माइंस में, वो देखिए मेटलर्जी वालों का एक आदत है, उनका कोई घर में गड़बड़ी होगा, बोले माइनिंग वाले के चलते मेरा गड़बड़ हुआ, वो अपना घर नहीं देखेंगे। माइनिंग बिकेम ए वेरी इजी प्रे ऑफ अदर्स। जब ये प्लास्टिक बोतल यूज हुआ इन लैक्स ऑफ नंबर्स इन जोड़ा ईस्ट माइन, उनका मेटलर्जी वाले हल्ला करने लगे, हमारा क्वालिटी खराब हो गया, ये हो गया। दे टुक द एयर सैंपल्स, दे टुक द सैंपल ऑफ द ब्लास्टेड आयरन ओर, सेंट इट टू ऑस्ट्रेलिया, टेस्टेड इट, could not find anything wrong. मजे की बात है, जब ऐसे में एनफो यूज कर रहे हैं, एक बोतल डालोगे तो 1 kg बारूद बचेगा। 1 kg बारूद जनरेट्स 14 kg ऑफ CO2 इनटू द एयर। ये एक्सपेरिमेंट कर रहे हैं, एंड मैं इसको कोई पेटेंट वेटेंट नहीं किया हूं, मेरा ओनली इंटेंशन लेट पीपल यूज द बॉटल्स। नादी नाला सबको जाम करके तो रखता है, पूरा देश बर्बाद है इसके चलते।
Dr. Pradhan.
I will take 2 more minutes.
2 minutes. Thank you.
So मेरा कहना है, जितना बोतल यहाँ पड़ा है लेके डाल दीजिए बारूद में। आप बोलेंगे क्या होगा? अरे भाई ये अच्छा ब्लास्ट करेगा आपके लिए, बिकॉज देयर इज एयर गैप इनसाइड इट, एयर गैप ब्लास्टिंग। ये घरेलू दवा है। अगर आप इफ यू आर रिच एनफ, देयर आर केमिकल्स अवेलेबल, chemical bags available costing 300 to 400 rupees. Put it inside the hole. ये तो फ्री ऑफ कॉस्ट है भाई। नेक्स्ट, this is explains how much CO2 is generated from dragline, shovel, dumper, blasting, blah blah. Another recent thing has come, digitization in blasting. We are far ahead in our country, but digitization doesn't mean that you stop human intervention. वो बारूद कोई कंप्यूटर से नहीं चलता है। बहुत लोग आपको आएंगे, इतना करोड़ का पैकेज ले जाओ, ब्लास्टिंग करो। सॉरी, यू हैव टू अप्लाई योर माइंड टू मेक योर सेल्फ सेफ। ज़्यादा डिजिटाइजेशन करेंगे बारूद में चलता नहीं है। इलेक्ट्रॉनिक डिटोनेटर ठीक है, क्योंकि वी कैन नॉट गिव द इनपुट दे वांट। दे ओ 18 इनपुट मांगेगा, हम क्या माइन चलाएंगे कि हम यहाँ को PhD रिसर्च करना है, हमको यहाँ ब्लास्ट करना है, इसका डाटा हमको जनरेट करेंगे, उसका स्टडी करेंगे, कंप्रेसिव जियोटेक्निकल पैरामीटर, तब तक बेंच यहाँ आ गया। तो डिजिटाइजेशन इज ए गुड एफर्ट, बट थोड़ा सिंपल वालों को रिक्वेस्ट है, ज़्यादा इसको बढ़ावा मत दो, हेल्प करो, प्रोजेक्ट लो, कोई दिक्कत नहीं है। but apply your mind. Thank you very much.
Thank you very much, Dr. Pradhan. Couple of questions for Dr. Pradhan, if we can. Yeah, right at the back there first.
Professor Pradhan, a very good presentation. My point is only what is the replacement for initiation ED, electric detonator? That please put some light on that. It's not a question, it's just common.
2024 में on the recommendation of Home Ministry, internal recommendation, they told that majority of the blast taking place in majority of the parts of the country.
Dr. Pradhan, I'd request you to use the mic because online is.
They are using electric detonators और इलेक्ट्रिक डिटोनेटर ब्लास्ट करना बहुत आसान है. थोड़ा बैटरी ले लो हो जाएगा. कोई ट्रक को खड़ा कर दो उसका बैटरी यूज कर दो हो जाएगा ब्लास्ट. It was so easy. It was so sparingly used by nuisance makers, anti-nationals. तो इसको बैन करने के लिए आया सजेशन. 3 बार रिपीट हुआ है. The third one letter came only recently. It should be banned forever. कंपनियों को बोला कि आप मैन्युफैक्चरिंग पहले बंद करो. So then the solution is that we have got electronic detonator. There is a gadget. एक बक्सा दे रहा है. You use that and trigger the blast. But I am telling you the best way to get rid of electric detonator is use OD and safety fuse. 99% of blast triggered in USA use safety fuse imported from India, imported from Nagpur. और ब्लास्टिंग देयर इन यूएस. वो घर का मुर्गी दाल बराबर है. हम लोग ओडी और सेफ्टी फ्यूज भूल गए. वैसे जला दो और भाग जाओ, बच जाएगा. बट थोड़ा आगे इलेक्ट्रॉनिक का शौक है हम लोगों को, डिजिटाइजेशन का. इलेक्ट्रॉनिक डिटोनेटर इज द सजेशन एंड मेजॉरिटी ऑफ द माइंस आर नाउ गोइंग फॉर इलेक्ट्रॉनिक डिटोनेटर ट्रिगर्ड बाय ए गैजेट प्रोवाइडेड बाय द मैन्युफैक्चरर.
Next question, please. Yeah, go ahead.
बोलिए.
Good afternoon, sir. Nowadays, most of the companies have stopped the manufacturing of the ED, and the consumption of ED is also banned in most of the metalliferous mines. My question is there any study that is nowadays most of the shock tube detonators are used in the mines which are initiated by the other device, which is a shock tube initiator? My question is there any study that the shock tube detonator can be is initiated by a stray current or a radio frequency or a weather lightning? Because, sir, most of the accident in the future, in the past, are happened due to a blast of a detonators, and which carried out with the explosive, which had the explosive just around it. And the most of the casualties what happened, and most of the accident happened because of the electric detonator, I mean to say. Is there any study regarding the shock tube detonator?
Shock tube detonator is one of the safest and best as far as global standards are concerned. We are nowhere behind them, global standard. So far, no reported accident has come out with shock tube detonator, but detonator सांप है. So you have to treat it as a सांप, not as a friend.
Exactly, sir. बस
क्योंकि डिटोनेटर ट्यूब में जो पीईटीएन है, जैसे एक छोटा पाइप में फूंक देते हो, बबल्स आता है पाइप में. Similarly, PETN has been put inside the pipe in particles, so it doesn't have much strength. अगर PETN 7000 मीटर पर सेकंड स्पीड में भागता है, वो हम भागने से रोक दिए. कितना है? Minuscule. So it is ultra safe. Don't worry about it.
Thank you, sir.
Okay, thank you very much, Dr. Pradhan.
I will have a last word. जितना भी अभी हमारा बंदिश आ रहा है because of Home Ministry एनफो पहले क्या होता था, हम लोग देखे हैं, सर लोग भी देखे होंगे, एनफो जो ब्लास्ट करता था, अरे भाई 4 बोरा एनफो भेज दो, सर ट्रक ने, अरे बस में डाल दो ना, स्टोर में जगह नहीं है, ठीक है, मैनेजर साहब अपने कमरे में रख देते थे। बट इतना मिसयूज हुआ एनफो का, आज एनफो को स्टोर करने के लिए मैगजीन, जो फैक्ट्री से एनफो निकलेगा और आपका पास आएगा, अगर 500 थाना है, एवरीवेयर दैट पुअर ड्राइवर हैज टू मेक एन एंट्री कि मैं इतना एनफो लेके एमोनियम नाइट्रेट लेके जा रहा हूँ। सो हमारा अभी जितना भी बंद, और दूसरा चीज क्वेश्चन नहीं पूछा है, आवर दिस वायरलेस सेट इज वन ऑफ द सेफेस्ट बिकॉज इट इज वन वे कम्युनिकेशन। जहां भी 2 वे कम्युनिकेशन है दैट इज एज गुड एज ए मोबाइल। अभी बीच में कुछ रंगीला, यूज दी वर्ड रंगीला, जिन बड़े कंपनियों के पास बहुत पैसा है वो लोग दे वेंट फॉर ब्यूटीफुल वायरलेस सेट्स। उसमें वो क्या किया, चिप को घुसा दिया। मैं जिंदल पावर का 207 मशीन को रिजेक्ट करवाया हूं बिकॉज दैट इज एज गुड एज ए मोबाइल। भाई वो बोलते प्रधान साहब मैं फेस में बैठ के दिल्ली बात करता हूं, मैं बोला मोहरोगे तुम, जमराज से बात करने जैसे हो जाएगा तुम्हारा। So please use as many as of wireless set and don't use any mobile because मैं बहुत गहराई से देखा हूँ वेस्ट बंगाल, थैंक्स टू ममता बनर्जी, हर एक को 32 लाख रुपया दिया और हर फैमिली में एक को सरकारी नौकरी मिला। क्योंकि इंडिया में कोई एक्सीडेंट हुआ तो नेक्स्ट वर्ड इन द न्यूज इज द इतना मुआवजा दिया गया। अरे उसका खानदान में क्या हुआ उसको सोचो ना। थैंक्स यू।
Thank you very much. And thank you very much, Devraj Saab. Wonderful, wonderful comment. These are all tools that we have learned to use, and the rules for using them safely are what makes us work. Thank you so much, Devraj Saab, for that closing comment. I'd like to invite the third presenter, please.
We invite our next presenter, Mr. Abhishek Bhadang, to please present on reclamation techniques in mining.
It's nice to see another youngster coming up. Please give him a big hand as he comes up. Thank you.
Good afternoon, everyone. My name is Abhishek Bhadang. I am from Rajiv Gandhi College of Engineering, Research and Technology, Chandrapur. I am a final year student. Till date, I have not been prepared for any research work, but I just presenting the reclamation on the brief introduction part. So let's start with this is the introduction index. Let's start with the introduction. Mining activities, while essential for economic development and resource extraction, often result in significant environmental degradation, including deforestation, soil erosion, habitat destruction, and land destabilization. To address these challenges, mine reclamation has emerged a crucial environmental management practice aimed at restoring disturbed land to a stable and productive condition. Reclamation techniques in mine involve a series of scientific, ecological, and engineering processes that aim to rehabilitate and improve soil health and re-establish vegetation. Objective: to restore ecological balance and rehabilitate degraded land through systematic revegetation, to improve soil stability and reduce erosion on the dumping site, to enhance biodiversity by planting a variety of native and adaptive tree species, to increase green cover and promote sustainable environmental practices, to create a self-sustaining vegetative ecosystem under the guidance of the Forest Department. These are the statutory provisions regarding the reclamation. Environment Protection Act 1986. It empowers the central government to take measures for the protecting and improving the quality of environment, including reclamation of degraded land. Forest Conservation Act 1980 regulates the diversion of forest land for non-forest purposes and mandate compensatory afforestation which align with reclamation efforts. Mines and Mineral Development and Regulation Act 1957 with Mineral Conservation and Development Rules 2017 mandates mine leaseholder to undertake progressive and final mine closure which include land reclamation and ecological restoration. National Forest Policy 1988 emphasizes the need for massive afforestation and soil conversion, particularly on degraded and dumping lands. One of the most Coal Mine Regulation 2017 107. This is also the part of the reclamation. Now coming to the types of reclamation, there are two types of reclamation: technical and biological. In the technical reclamation, we have backfilled the topsoil and subsoil, gradient backfill, and depend on the type of equipment used to mineral work. Various combination of equipment can be used for reclamation, like backfilling, spreading, stacking, scarifying, grading, and etc. Biological reclamation. In this process, soil amelioration and mulching will be done. The plant species will be planted in that after the technical reclamation. Benefits of biological reclamation include reduced environmental degradation, improve aesthetic value, and the creation of habitats for native species. Additionally, it supports carbon sequestration and helps reduce the spread of invasive species. Overall, biological reclamation is essential for the long-term ecological recovery of mine lands. These are the methods with the combination of shovel dumper combination, reclamation with shovel dragline combination, reclamation with bucket wheel excavator, and reclamation with shovel directly loading into the railway wagons. Necessity, environmental restoration. These are the most important. Reclamation helps restore ecological balance by reviving flora and fauna and improving soil and water quality on degraded mine lands. Soil stabilization and erosion control, revegetation and land contouring prevent soil erosion, reduce sediment runoff, and stabilize loose overburden and dump slopes. Sustainable land use. Reclaimed land can be purposed for the agriculture, forestry, grazing, and recreational use, adding long-term value to the landscape. Compliance with legal regulations. Reclamation is often a statutory requirement under the environmental and mining laws, ensuring responsible closure of mining operations. These are the mines we have. Gauri Deep open cast mine, which is situated in Ballarsha area, Chandrapur. Physical reclamation is carried out with the help of shovel dumper combination. And another one mine is Sasti open cast mine. These are also from Ballarsha and Neyveli Lignite Corporation. Bucket wheel and shovel dumper combination will be adopted for that. These are the pictures in the Gauri Deep open cast mine. Conclusion. Now coming to a conclusion. Reclamation in mines is a critical aspect of environmental sustainability, and its importance cannot be overstated. The Indian government and mining industries have taken steps toward the land reclamation, but challenges persist. To ensure effective reclamation, it is essential to implement sustainable practice, adopt environmental friendly mining methods and rehabilitation techniques, increase the pace of reclamation, expedite the reclamation process to minimize environmental degradation, ensure compliance with the regulations, enforce environmental laws and guidelines to prevent non-compliance, continuously monitor and evaluate, regularly assess the effectiveness of reclamation efforts, and make necessary improvements. These are the reference, and thank you for.
Thank you very much. It was a wonderfully short and sweet presentation. Again, I'd like to thank Abhishek, right?
Yes, sir.
Abhishek, for this presentation. Any questions for Abhishek? Or any comments to support him? Okay, I'd like, oh yeah, go ahead.
Very good presentation, Abhishek.
Yes, sir.
Can you tell me what is the height of that dump, Gauri Deep?
Actually, sir, I am not vocational training. I have done in the Gauri Deep, but no sufficient data for me.
Abhishek, I have a question for you.
Yes, sir.
Not a question, actually, it's a comment. Okay, and it's relevant to all of us here right now. Whenever we think of reclamation or rehabilitation or resettlement as a statutory requirement, we do what is minimum, and we consider that cost as only the cost as outgo. When we consider reclamation as a process which is part of our mining and not just regulatory, it is something that comes from our heart. In that case, and when we evaluate the cost of implementation of that regulation or that reclamation and the benefits of that reclamation, then it makes sense for us, okay? So whenever we look at sustainable mining practices, sustainable practices, let's just, put that into our cost sheets as well. See what the impact of that on the cost sheet is, not just as an expense, but as what are the benefits of doing that. Because as long as we treat it only as a regulatory compliance, we will always have a problem. Once we treat it as part of our system, and again, I mean, there are companies, mining companies, but we are all proud of our mining companies because we do it as a standard practice, including Lloyds Metal. Hindustan Zinc does a lot of that. Hindustan Copper has done a lot. Coal India has done a lot. These are lessons to learn and lessons to share, and I'm very happy that many of our large companies are doing that. It has to trickle down to all of us to make sure that we're not just doing a compliance, we are actually doing a benefit to the community. Thank you. Would you like to sum up? No, this next presentation. We have corporate presentations. What? Okay, we'll do that.
Let's now turn our attention to a presentation by our platinum sponsor, Ultratech Cement Limited. Let's welcome Mr. Advait Saxena, Senior Manager Mines Operations from Ultratech Cement, to take the stage.
Thank you. Good afternoon, all. Myself, Advait Saxena. I am working in the Ultratech Cement Limited, Manigarh Cement Berg. I am presenting the overview of Aditya Birla Group. So, we are the premium global conglomerate for USD 100 billion market capitalization. We are in the 500 top Fortune companies, and we are in the 6 continents. We are in the 6 continents over the 14 plus countries and we are having the 187,000 employee all over the 100 nations, and over the 7 decades. We are the top employer in 2025, we are the top employer by the TEI. So we are the third largest cement manufacturing, excluding China. In India, we are the first. And the RMC plant, we are having 395 RMC plant in India. And of course, building solution, we are also providing the building solutions. Our building solution stores are 4,615, and we are leading player of the white cement also and putty. So our mission and vision. So one more thing I want to add here, that our values, we are working in the values. The values is integrity, commitment, passion, seamlessness, and speed. These are the 5 values of UltraTech Cement and Aditya Birla Group. So we are working on this. So our mission and vision. So mission is innovation, customer centric hai, and sustainability. Sustainability is main. We want to share that in this 2023-24, we got the 5-star rating awards in 13 mines, and out of 13, one is 7-star. That is Awarpur Cement Works. So we are that is this achievement shows what we are doing in the sustainability. Dr. Gurpreet बता रहे थे कि वो LPC के बारे में. We are also 7.8 kilometer LPC in the Manigarh Cement Works. It's undulating terrain, and of course में एक डैम भी है और बहुत sustainable मतलब mining है उसमें, sorry, transportation system है. We are not using any truck and all these things. Ropeway is I think 1986 में ropeway था, then now it is a LPC. So LPC and ropeway both are running in 7.8 kilometer undulating terrain. So team empowerment, of course. So these are the our grey cement. In the grey cement, we are now having 188.76 metric ton in 2025. Our target is in 2027 200 plus 200.5. So in the white cement 1.3 MTPA and white putty 1.3 MTPA. Or earlier I have already said 395 RMC plant in 155 cities we are running, and we are also providing the building solution, that is 4,615 outlets in 223 states. So first cement plant we have commissioned in 1983 with 1 MTPA. Now we are in 188.8 MTPA. So this, see the successful journey. Now in 2027, our target is to achieve 215.9 MTPA. These are the product range in Birla White. So product offering based on the requirement. So we are offering on the basis of the customer requirement. So this revenue we are generating in 6,100 crore rupees, or these are the footprints in India. So we are also providing the steel roofing type of categories जो हम लोग इसमें deal कर रहे हैं. Steel roofing and seats, electricals में sanitary and fittings में plywood and power wall, PVC pipes and water tank. Solar power we are also इसको सोलर पावर्स को भी देखने की कोशिश कर रहे हैं अभी, किसी से हम लोग ही चल रहा है, एंड सोलर पावर भी जल्दी अल्ट्राटेक के वन रूफ के अंदर आ जाएगी. सो दीज आर द प्रोडक्ट्स, ओवर 54 प्रोडक्ट्स वी आर डीलिंग. So grey cement, I have already told you, in 2024 140.8 million ton, and this year 183.4, or now we are targeting for 210.5 metric ton. Million ton. So now we are having the 35 integrated units, 34 grinding units, 10 bulk terminals, 2 white cement, 3 putty units, and 5 jetties. So now I want to, because I am mining guy, that's why I am skipping all these things. So this year already I have shared this 7-star rating we have got in the Awarpur Cement Works. So we are working for the sustainability, and one of the good example that Manigarh and Awarpur swapping some material which is a low grade for Manigarh. It is swapping towards the Awarpur Cement Works, and Awarpur also sharing some shifting the material that is low grade for the high MGO material there to Manigarh, and this year we have swept allowed around 4 lakh ton. So we want to achieve now 6 lakh ton this year to towards the waste mining, minimize of waste mining. So thank you.
Thank you very much. Would anybody like to ask some questions? Yes. Right in front here.
Ji, sir.
Your mic देंगे उनको please. Yeah. The reason I'm insisting on mics is because this is being streamed also.
Saxena, a very nice presentation. And you were talking about your mines. You are using the limestone, sharing limestone from Ultratech to Awarpur to Manigarh, Manigarh to Awarpur.
Yes, yes.
I can know some deficiency of the elements, minerals in your cement. So you are using the additive in your mines?
Yes, our deposit is, Manigarh deposit is...
how percent is using additive?
Manigarh having the high silica and high CO3, but less than 1% Al2O3, Fe2O3 and MgO. Awarpur having low silica means it's around 8, but MgO is too high, 8% aspas. Then
how much silica in Manigarh?
Manigarh is 15, average 15.
15?
Yeah.
So 15 is sufficient for the cement?
No, 15 to 18, we are swapping 15 to 18, average 15 we are maintaining. So high MgO material we are taking, by default we are getting 2.5% of Al2O3 and 2.5%, around 2.5% Fe2O3.
How much magnesia in Awarpur?
It's, they are using less than 4 and more than 4 they are sending to Manigarh.
Okay. Yeah. Thank you, Saxena.
Yes. Paper waste is also that using by that is called slime slush, I think. But we are Manigarh not using, but Awarpur is using that lime slush. That but उसमें क्या है कि थोड़ा moisture ज़्यादा है, then उसको dry करने के लिए उसको spread करना पड़ता है benches में, और काफ़ी time के बाद फिर उसको blend करके उसको use कर लेते हैं.
One more thing, Awarpur has some problem of the sulfur.
Yeah.
So any help from the Manigarh material?
Yeah, we are having less sulfur material. They are having more sulfur material. So swapping is मतलब almost सभी चीज को वो compensate कर रही है. We are procuring around 8% of this laterite and bauxite. Okay, now we have reduced 2%. Now 6%. Target is 4%.
Using lignite in kiln? Using lignite?
That I don't know.
Okay. Can we continue the technical discussion?
Thank you.
Thank you. Any other question? One more question, please. Okay. Thank you very much for the wonderful presentation from Ultratech Cement. Thank you.
Thank you so much. We have another corporate presentation from our platinum sponsor, FLSmith. I invite on stage Mr. T. Senthil Kumar, DGM Mining Capital Sales, Greater India from FLSmith. Thank you.
Good afternoon, one and all. Good afternoon, sir, chair, co-chair. It's indeed a privilege to be part of this event, and then being a platinum sponsor for the event makes us even more special. When I was looking at the agenda, I was also very happy that this particular presentation is slotted very aptly in the sustainable related presentations. Thank you for that. And I am Senthil Kumar, and I'm DGM of Mining Capital Sales. I'm based out of Chennai, and we are part of the region where the area of activity is Greater India. which covers basically India and the neighboring countries, including Oman. So with that, I know I'm standing in between the lunch and you. Please don't dislike me. I'll try to make it as interesting as possible. So as a tradition in FLSmith, we start with the safety share of a gathering, which is more than 4 people. So just a quick safety share. The picture says it all. This is about a safety share from a laboratory. Laboratories are places where the samples are collected all over the plant and also from the mines, and then they are tested for consistency and quality. So these laboratories can become really dangerous if proper SOPs are not in place, proper safety precautions are not taken, proper automation is not taken into account. So on the right-hand side, as you can see, in laboratories, they deal with high temperatures, toxic fumes, acids, and things like that. So putting in an automated system there will greatly enhance the safety level of the operations in the laboratory. So being a corporate presentation, would like to briefly give about what is FLSmith for people who are already not aware of it. So just a quick numbers. The numbers are for you, for your eyes. You can see that we are a company with 145 years plus tradition of legacy. And then we are financially about $3 billion turnover company. And then we are placed in 60 plus events as well. Sure. Who are we? We are a full flow sheet equipment, technology, and service provider for the mining industry. And then we help our customers in achieving greater performance, greater cost reduction, cost efficiency, and then improving the performance and also their sustainability goals. We have set ourselves an ambitious target of achieving Mission Zero for our customers by 2030, and then we have done great progress in that as well. You know, we are very well aware of the current macroeconomical environmental challenges what we face. Having said that, you know, the energy crisis, the geopolitical situation what are in right now, and then all the time there is a scare of recession staring at us. And then these challenges also help us in strategizing, in reaping the opportunity and then plan our strategy for it. So that is how we are working on. And our core 26 is the strategy for FLS, which we have it built in inside FLS to take care of those challenges for our mining division. So those core 26 strategies are basically built on these 4 pillars. One is sustainability, where we are building a mine for the future, and then the technology which gives cost efficiency and performance improvement, and then the performance as such by providing business simplifications and balanced risk when you go in for the implementation of the technology and plans. And then providing a full service, lifecycle service support for our mining customers, also to ensure they are also sustainable in their production. And then just a quick look at what are we doing at the sustainability front. You know, even for sustainability, minerals are very essential when you want to make the green transition. So when you want to make the green transition, just to put it in a case in front of you, 2021, we were like about 7 million, we had about 7 million battery EVs and PHEVs in production, and then that is expected to go up 7 times by 2030, which means 6x the volume of minerals are going to be needed for the transition. So, and more and more we are moving towards wind energy as well. And when you do that, for a 3 megawatt wind turbine, we are looking at, the numbers are mentioned there for the number of so much of concrete, steel, copper, aluminum, and rare earth elements. So this is again going to go double in the capacity between 2021 and 2030. So again, all these minerals are very vital for the green transition as well. So what we have done is, we have put up our strategies for the Mission Zero mine, achieving a Mission Zero for 2030. We have put in our strategies and then our efforts in the form of a Mission Zero mine, which can be very handy to our customers as well. So with this, we want to achieve, we want to help our mining customers to achieve zero emissions by 2030. We are already working with a lot of great customers, and then plenty of case studies are available with us where we have done it in sections for them already. So basically what we have done is, we have modeled what would be the impact if you try to replace the regular conventional ball mill, sag mill, ball mill based grinding circuit, flotation circuit, and basically a wet circuit. When you try to replace that with the highly advanced technological developments which have come in on this front, which will support our sustainability goals. So that is what we have tried to put in here and make a model out of it. This is basically an interactive Mission Zero mine flow sheet, which is available in our website as well. Please, when you have time, please go through it. It's a very interactive Mission Zero mining flow sheet. So as you can see here, in this case, what we have done, we have basically taken a 1 lakh ton per day plant of this mineral processing circuit, and then try to replace that with, see, for example, we have, that's fine. As you can see, starting from the power generation, we are talking about going for windmills and alternative sustainable power sources, thereby having a 30% overall reduction in the power consumption. So, and then we have about replacing the regular conventional sag ball mill grinding circuit, which are the most power consuming circuits in a mineral processing circuit. So by doing that, we already projected about 30 to 35% reduction in the power consumption. And then just by going in for today, we also had our colleague presenting about HPGR technology. So by going in for those technological crushing circuits and grinding circuits, we are even avoiding the steel balls which are being used in the sag and ball mills. So that is even estimated to be accounting for about a 1 lakh ton for this CO2 equivalent emission. So, and HPGR, of course, we saw it in detail. This can give about 80% reduction in water consumption when going in for a dry circuit. We have implemented such grinding circuit for one of our prestigious customer, is an Indian steel maker out in Oman. So we have done basically a water scarce place where we have gone for a combination of wet and dry grinding circuit. So thereby saving water consumption. And then similarly, we have technological advancement at every place. For example, the flotation cells. Flotation cells, we have come up with a reflex flotation cell. Those are very high efficient. And then they again project about 45% of power consumption saving. And then going in for EDUC-based feed dilution technology on the thickeners, we are talking about very high efficient feed dilution, which means your thickening process efficiency is greatly improved, which means your downstream again are becoming more efficient. So if you see, we are discussing in pockets, which means when you put all of these together, definitely they are much more efficient than the individual boxes. So that's basically what the Mission Zero mine is all about. See, for example, when you talk about HPGR, that does, when you do the crushing, it does reduce the bond work index of the ore by creating minor cracks within the ore, which means the grinding circuit, which is a secondary grinding circuit, already consumes a low power because of the minor cracks and reduction in bond work index. So that's how, when you see the complete flow sheet, it's even more efficient than doing it in individual sections. So this is something I'm not going to do much because we saw it already from a colleague. So this is another version of the HPGR Pro, which is even more efficient than the previous versions. And then when it comes to the technology part, when you talk about the mining value chain, we play a role in our mineral processing area. And then, of course, those are the major focus area for us. And then within them, these are the product portfolio and technology available with us in terms of starting from input crushing and conveying stations. Going in for these will drastically reduce the fleet, the long fleet we have, moving the entire burden from the crusher to the plant area or the crushing station area. So we also have the conventional crushing and screening equipments. And then we have the ball mill, sag mill, ball mill, and also rod mills. We have vertical mills as well in terms of FLS tower mills, which we are offering to customers here in India as well. That project is under execution. Those are highly energy efficient. And then we also have technology for providing full pyro-based technologies like gas suspension calciner, and which finds application in alumina refinery. And then we also have the highly efficient pumps and cyclones portfolio with us. And when it comes to separation, again, we have a complete range of products, including the very high efficient recent RFC technologies. And then when it comes to thickening filtration, again, we are highly efficient in the thickener side with our EDUC technology for feed dilution. And we are also having a unique product portfolio, which many of our competitors do not have, is the sampling preparation and analysis, which means taking a dry or a slurry sample and even automatically taking samples doesn't simply mean extracting material from the process or mine. It means following ISO standards and taking representative samples out of them and then transporting them automatically to the laboratory by automatic transport systems. And then even at the laboratory side, we have the full range of equipments to make a fully automated robo-based laboratories. So when it comes to R&D and innovation in the mining sector, we concentrate on all of the entire flow sheet of equipments, and then our predominant focus is on them. And then we have a dedicated R&D testing and research center in the US, Salt Lake City, where we will be able to do the mineralogical characterization, metallurgical testing, and these are predominantly used for selection of equipments and then even designing a flow sheet, or sometimes when you want to do a retrofits and upgrades, that is also possible. This can come in handy. And then plant troubleshooting as well. And then, of course, we are no different, and we are pioneering this one in the digitalizing our entire flow sheet. And 50% of our R&D funding is also going towards digitalizing our own products, and also on the customer process side. We have a long history of having our own portfolio of products when it comes to digitalization. This is just to give an idea of how we are doing it in a meticulous way of digitalizing individual products. This is always works well when you go from bottom-up approach. Then it becomes the data transfer from the local and the individual equipments becomes very vital when you take decisions on the top level. So just an example how digitalization can help you in reaping benefits and also achieve your sustainability goals. So we installed this small instrument called Load IQ, which is basically a sensor attached to the shell of the mill, SAG mill. And then in one of the installation where we had about 40 by 24 feet mill, SAG mill, we had installed three of those mills. And then this sensor will help you to understand the, when it comes to the grinding, there are few key parameters which are called feed and throw. When you can clearly identify the feed and throw of the mill material inside the mill, this helps in a great extent of saving your wear liner and also creating a better impact of the material and efficient grinding. So as such, the place where we have installed this one, which I'm referring to, we have got about 10% increase on the throughput, 8% reduction on the energy consumption, and then also increased wear liner life. So to support all of these, we also need to have efficient life cycle service support infrastructure. That is basically what is the category of services what we provide for the consumables, digital services in assessing your performance of your equipment, benchmarking them for within your plant and global standards. So we have services, and then we have professional services to look at your efficiency on plant, equipment, and then improve them, providing you with spares, and then retrofits and upgrades. So that is also part of your life cycle support. So just for your eyes, we are spread across the globe. Wherever your installation is, you are not too far away from one of our service centers. So with that, thank you.
Any questions for Senthil? Yeah.
What is your success rate in tailing filters?
When it comes to tailing filter, we have installations for iron ore tailings. So, of course, tailing is a different material altogether, because it's even in red mud, we don't have reference for red mud as such, but we have products in every other application which filters have been done. For example, drum filters. We have done hundreds of drum filters even for the red mud, but when it comes to automatic filter press, we are still looking at.
I'm talking about iron ore.
Iron ore. When it is iron ore, yes, we have installations in India as well. Initially, yes, it was a struggle in terms of, it is very important for us to really take care of the filter cloth and the mechanisms specifically for the application, because tailing is tough, as you know, it's a tough application to handle. But right now, it's running great and customers are very happy. Yeah.
I mean, which customer is happy?
Maybe I can tell you personally.
No, because I have seen your installation, that's why I'm asking.
I know, I guessed it.
Okay. Any more questions? No other questions. Thank you very much, Senthil. Big round of applause for another of our Platinum sponsors.
Thank you so much. Thank you for the opportunity, sir.
Thank you. To wrap up this session, I request Dr. Shrikant Annavarapu, former professor IIT Kharagpur, and Dr. Sanjay Sarkar, DGM Oil, to kindly share their final thoughts with us.
Namaskar, good afternoon to all of you. Before conclude this session, I would like to express my sincere thanks to all the presenter and author for their exceptionally good presentation and their contribution towards our mining sector. Total 3 technical presentation and 2 corporate presentation has been presented in this session. I will not go in detail because due to time constraint, I will not go in detail. But all the presentation are very relevant to present mining scenario. I am also express my sincere thanks to chairperson for conducting this session well in time. Thank you very much.
another wonderful session in a mining seminar. And a very important one, like I've been saying in my two little interjections, sustainability should be a practice, not a compliance. And let's make that happen. Number two is cost. Let us remember that we are all mining folk, and our purpose is to monetize the mineral resources. And when we monetize the mineral resource, means that every part of material that we move, there must be, there is a cost associated with it. Reducing that cost and trying to earn from whatever material we are transporting, that is key. That is the key to sustainability. I think all the papers that we have heard today, the two presentations, the corporate presentations also, they have shown what we can do, and they're repeating what we are already doing. It's seminars like this, we learn from each other and use the best practices to continue sustainability. Thank you very much.
Thank you so much, sir, for such well-articulated concluding remarks. To express our thanks to the speakers, I request Dr. Shrikant Annavarapu and Dr. Sanjay Sarkar to please felicitate our speakers. I invite on stage Dr. Gurdeep Singh. Ladies and gentlemen, please give a huge round of applause. Next up, I invite Dr. G.K. Pradhan. May I call upon stage Mr. Abhishek Bhadang. I invite on stage Mr. Advait Saxena. I now invite Mr. T. Senthil Kumar. I would now like to invite on stage Mr. A. Janardhanan, who had presented in the previous session. Thank you so much. With immense respect and gratitude, I would like to thank Dr. Shrikant Annavarapu and Dr. Sanjay Sarkar. I now invite Mr. Shailendra Kumar, Controller of Mines, Indian Bureau of Mines, to kindly present a token of appreciation to Dr. Shrikant Annavarapu and Dr. Sanjay Sarkar. Ladies and gentlemen, please give a big hand. Thank you so much. Now it's time for a break. Please proceed for lunch before we reassemble for the last session of this seminar. We'll see you back in an hour. Thank you.
Stay with me if you wanna.
May I have your attention, please? I request everyone to please settle down. We'll begin in 5 minutes. I request everyone to please take your seats. We are all set to begin. We now move to the final session of this seminar. The theme we are going to discuss sits at the intersection of strategy, sustainability, sovereignty, critical minerals. From lithium and rare earths to tailing recovery and defense preparedness. This session reflects on India's roadmap to securing its future in an increasingly resource-sensitive world. And I would request Shri S.K. Adhikari, Chief Mining Geologist, Indian Bureau of Mines, and Shri Suresh Vandhare, General Manager, JK Cements, to chair this session. I request Shri S.K. Adhikari and Shri Suresh Vandhare to kindly come on stage. Ladies and gentlemen, with a big round of applause, please welcome Shri S.K. Adhikari and Shri Suresh Vandhare. I'd like to call our speaker, Mr. Satish Shenvai, who would present on unlocking the pathways through knowledge sharing for critical mineral.
Distinguished guests and eminent participants, Namaskar and good day. आप लोग सब देख रहे हैं कि दिस इज द सिनेरियो फॉर लिथियम मिनरलाइजेशन इन होल वर्ल्ड. अभी अभी हम लोगों ने हमारा खाना ख़त्म किया है. नॉर्मली हम लोग हमारे खाने में भी ये सब चीज़ को देखते हैं कि क्या चीज़ अच्छी है क्या नहीं है, और क्रिटिकल रेयर ये सब इसको हम लोग विजुलाइज करके हमारा खाना कंप्लीट करते हैं. इसी प्रकार से अभी हम लोग को सबको कॉन्सेंट्रेट करना है हमारा क्रिटिकल मिनरल एंड रेयर मिनरल. यही पैशन को लेके मैं थोड़ा आगे बढ़ रहा हूँ. और अभी अभी जिम्बाब्वे में एक ग्रुप के साथ में, इंडियन ग्रुप के साथ में मैं एसोसिएट हुआ फॉर लिथियम एक्सप्लोरेशन. द प्रिलिमिनरी एक्सप्लोरेशन हम लोग जिम्बाब्वे में मैस्विंगो करके एक एरिया है, एक प्रोविनेंस है 300 किलोमीटर फ्रॉम हरारे, कैपिटल ऑफ जिम्बाब्वे. So that company is from मुंबई, अवनी माइक्रोलाइट प्राइवेट लिमिटेड. और अभी भी इनका महाराष्ट्र गवर्नमेंट के साथ में MOU हुआ और नागपुर में मिहान में एक लिथियम रिफाइनरी का इनका एक फ्यूचर प्रोस्पेक्ट है. ये जो आप देख रहे हैं यहाँ पर, तो ये पिगमेटाइट एक रॉक है विच इज़ द मदर रॉक फॉर ऑलमोस्ट ऑल द क्रिटिकल रेयर एलिमेंट्स. लिथियम, बहुत सारे वैल्यूएबल मिनरल्स इस रॉक के साथ एसोसिएट होते हैं. और ये क्लस्टर फॉर्म में हमारे इंडिया में भी है, मैं आगे आऊँगा उस बात पर. और इसी चीज़ को हम लोगों ने जिम्बाब्वे में जाके वास्ट उसका स्टडी किया, कुछ एरियाज फाइंड आउट किया. सो दीज आर दी पिगमेटाइट क्लस्टर्स. अभी मैं बहुत से गवर्नमेंट डिपार्टमेंट्स में या बहुत सारे जियोलॉजिस्ट के साथ में इंटरेक्ट करता हूँ. और हमारे देश में भी काफ़ी कॉन्फ्रेंस और ये सब में हम लोग क्रिटिकल मिनरल रेयर एलिमेंट्स ये सब बात करते हैं. लेकिन अनफॉर्चुनेटली हमारे जियोलॉजिस्ट लोगों को एक्सपोजर नहीं है इसमें, कि वो बोलते हैं हमको सैंपल दिखाओ, हमको सैंपल ही नहीं मालूम अभी तक कैसा दिखता है. सो इसलिए मैं थोड़ा ये सब मैं बहुत थैंकफुल हूँ डॉक्टर काये सर और श्री गुराम सर का, कि उन्होंने मुझे ये सब शेयर करने के लिए आप लोग के साथ में यहाँ इन्वाइट किया था. सो ये जिनवल्डाइट बेसिकली ये माइका फॉर्म में है. देन स्पोडुमेन, दिस इज स्पोडुमेन ओवर. सो इसमें एसिकुलर एंड ब्लेडेड फॉर्म ये पिगमेटाइट के साथ में एसोसिएट है. नेक्स्ट इज जब फील्ड वर्क में पाथ फाइंडिंग एलिमेंट्स ये बहुत इंपॉर्टेंट है. सिमिलर कंडीशन इज देयर इन इंडिया एंड ऑल्सो इट इज़ देयर इन जिम्बाब्वे ऑल्सो. काफ़ी डेंस फॉरेस्ट है. इसमें आपको जो प्राइमरी पाथ फाइंडिंग एलिमेंट है दैट इज़ पिगमेटाइट रॉक, इसको ढूंढना है. तो ये स्ट्रीम कटिंग्स में ये मिलते हैं. देन रोल्ड आउट एक्सपोजर जो है पिगमेटाइट के, ये हम लोग को वहाँ पर पहले ट्रेस आउट हुए. देन इस प्रकार से पिगमेटाइट वेन जब ट्रेस हो गई उसको पूरा ओपन किया गया, तो ये ऑलमोस्ट 200 to 300 मीटर्स का पूरा एक स्ट्रेच है कंप्लीट. एंड दिस इज इट कंटेन्स लिथियम, टिटेनियम, सीसियम, स्ट्रॉन्शियम, इस प्रकार से वैल्यूएबल मिनरल्स इसके अंदर में है. ये प्रिलिमिनरी इन्वेस्टिगेशन था. इसमें सरफेस सैंपल्स, चैनल्स और ग्रूव्स करके कुछ सैंपल्स हम लोगों ने लिफ्ट किए, क्योंकि प्रिलिमिनरी ये देखना जरूरी है कि ये पिगमेटाइट मिनरल बियरिंग है या नहीं है. भले ही आपको अदर जियोलॉजिकल कंडीशंस इसमें फेवरेबल है, लेकिन हमको ये टेस्ट करना है. और ये टेस्ट रिजल्ट एकदम पॉजिटिव आए। इसमें लिथियम, सीसियम, टंटलम और रुबिडियम, ये सब के रिजल्ट देखने के बाद में ऐसा लगा कि नहीं, इसमें भी आगे बढ़ना चाहिए। और इसमें फ्यूचर में हम लोगों ने जो आगे नेक्स्ट डिटेल इन्वेस्टिगेशन जो इट इज़ AI बेस्ड इन्वेस्टिगेशन हैज़ बीन गिवन टू सम ऑस्ट्रेलियन कंपनी एंड नेक्स्ट मंथ द डिटेल एक्सप्लोरेशन इज गोइंग टू बी। अभी हमारे देश में भी गवर्नमेंट ऑफ इंडिया काफ़ी इंटरेस्ट इसमें ले रही है, क्योंकि हम लोग को ये सब मिनरल्स जो है बाहर से हम लोग इसको इंपोर्ट करते हैं। और शायद आप लोग को इसका जानकारी होगा कि ऑलमोस्ट ये सब जो क्रिटिकल एलिमेंट्स है ये सब मोर देन $40,000 पर टन, ये रेंज है। इसके अबव रेंज के कॉस्ट में हम लोग को ये सब इंपोर्ट करना पड़ता है। तो अभी एज ऑन टुडे हमारे यहाँ कोई एक्टिव माइनिंग कोई प्रोजेक्ट अभी नहीं है। जो फर्स्ट ब्लॉक अभी कोरबा में अलॉट हुआ है, जो साउथ माइकी, उनसे भी मेरा एसोसिएशन अभी चल रहा है। सो दे आर इनटू द फर्स्ट स्टेज ऑफ लैंड एक्विजिशन। अभी इसमें ये जिम्बाब्वे में पिगमेटाइट और लिथियम की स्टडी के साथ साथ मेरा पास्ट में जो भी इंडिया में एक्सपोजर था उसके साथ में जब इसको कंपेयर किया, सो मैं देख रहा हूँ कि हमारे पास में फूड है, बस हमको थाली में अरेंज करना है। हमारा जो पिगमेटाइट का बेल्ट है बस्तर मालकनगिरी, ये ऑलमोस्ट 80 किलोमीटर का बेल्ट है। एंड एट दैट प्लेस व्हेन आई वाज देयर फ्रॉम 1993 टू 1998 वर्किंग फॉर मल्टीनेशनल हेमको माइनिंग एंड स्मेल्टिंग लिमिटेड। सो हमको ह्यूज पोटेंशियल और जो भी पिगमेटेड वेन को हमने एक्सपोज किया उसमें कैसेट्राइट मिला है। द टोटल एरिया ऑफ 80 किलोमीटर स्ट्रेच, उसमें जो एंशंट पाथ से एंशंट स्लोप्स थे, वो उसमें जो ग्रेवल जोन में पूरा 3 कैसेट्राइट, नियोबियम, टंटलम, इसका काफ़ी बड़ा भंडार हमारे देश में खुद है। और इसके ऊपर में बहुत अच्छा वर्किंग है। इसमें GSI ने काफ़ी रिसर्च वर्क किया है। लेकिन हम लोग को अभी जो चाहिए कि हमको एग्जीक्यूट करना है, हम लोग को प्रोडक्शन करके हमारे देश के लिए एक इकोनॉमिक बेस डेवलप करना है और खुद का भी करना है। तो ये बहुत ज़रूरी है कि हम इस सब जगहों पर जीवन लेवल का एटलीस्ट एक्सप्लोरेशन करें। या तो जो कंपनी अभी इंडिया से बाहर इंटरेस्ट ले रही है उनको यहाँ हम लोग इन्वाइट करें और डायरेक्टली उनको वहाँ पर जीवन लेवल या उनको डिटेल एक्सप्लोरेशन करने के लिए प्रेरित करें। ये वो बेल्ट है। तो ये जगदलपुर से मुझे ये ऑलमोस्ट दंतेवाड़ा से स्टार्ट होकर मालकानगिरी तक जाता है, 80 किलोमीटर का बेल्ट। ऑल द पिगमेटाइट क्लस्टर्स आर देयर। और इसमें काफ़ी बड़ा भंडार हमको कैसेट्राइट, नियोबियम, टंटलम, लिथियम, और इसमें जो भी GSI का रिसर्च वर्क हुआ है साइंटिफिक, इसमें इसकी जो केमिकल एनालिसिस रिजल्ट है दे काफ़ी इनकरेजिंग। सो हम लोग अभी ये स्टेज पे हम लोग है, लेकिन हम लोग इसमें बहुत सीरियसली सोच के इसमें आगे बढ़ना है। सिमिलरली इसी प्रकार से और भी कुछ केसेस है। ये तो हो गया दंतेवाड़ा, बस्तर, ये 80 किलोमीटर बेल्ट। सिमिलरली व्हेन आई वाज वर्किंग फॉर एक्सप्लोरेशन ऑफ मैग्नेसाइट, एक एनिमेटी एक्रेडिटेड कंपनी नागपुर बेस्ड है, मिस्टर PRB इंफ्रा प्रोजेक्ट्स, मिस्टर रवि रघुशे इज देयर। सो इनके एसोसिएशन में जब मैग्नेसाइट के लिए मैंने काम किया तो उस बेल्ट में भी देखा कि टोटल जियोलॉजिकल फीचर्स जो है दे आर सपोर्टिंग फॉर रेयर अर्थ एलिमेंट, लिथियम एंड ऑल दैट। एंड काफ़ी पिगमेटेड क्लस्टर्स यहाँ है। और कुछ वर्क एटॉमिक मिनरल ने भी किया है, तो उसके एडजेसेंट मंड्या डिस्ट्रिक्ट में वहाँ पर भी उनको लिथियम ट्रेस आउट हुआ है। सो ऐसे सिलेक्टेड एरियाज़ में बहुत ही रिगरसली टोटल एनिमिटी अपना फंड उधर डाइवर्ट करे। मैक्सिमम जो एलिमेंट एक्रेडिटेड एजेंसीज है उनको वहाँ प्रोजेक्ट अलॉट करे और एटलीस्ट 1 या 2 रनिंग माइंस को वहाँ पर एग्जीक्यूट करे। यही देन नेक्स्ट वेरी इंपॉर्टेंट पार्ट इज़ आवर संसर सीरीज। ये पूरा मैंगनीज बेल्ट जो है बालाघाट से लेके छिंदवाड़ा तक वाया नागपुर, इस प्रकार से। सो इसमें भी मैं बहुत काफ़ी माइंस के साथ में जब एक्सप्लोरेशन किया तो देखा कि जो कंट्रोल ऑफ मिनरलाइजेशन है तो वहाँ उसमें क्वार्ट्ज वेन एंड पिगमेटाइट का बहुत बड़ा रोल है। एक मॉइल की माइन से सीतापटोर या बहुत काफ़ी कुछ और माइंस है, वहाँ देखता हूँ कि ये पेगमेटाइट को अभी उनके लिए तो वेस्ट रॉक है, उसको बाजू में उठा के फेंक देते हैं, लेकिन फ्यूचर में ये सब सोचना चाहिए कि इसका प्रॉपर सैम्पलिंग, इसमें डिटेल इन्वेस्टिगेशन होके इसको आगे बढ़ाना चाहिए। बस यही मेरी इच्छा है और यहाँ मैं स्टॉप करता हूँ। और इसके साथ साथ हम लोग को मेनली जो इन्वेस्टर्स है, एस्पिरेंट्स है कि जिनको ऐसे कुछ माइनिंग में इंटरेस्ट है, इंडिया में काफ़ी छोटे बड़े ग्रुप्स है, बड़े माइनिंग प्लेयर्स तो बाकी मिनरल में काम कर रहे हैं, लेकिन ऐसे कुछ क्रिटिकल और ऐसे इसमें काम करने वाली काफ़ी कंपनियां इंडिया में है, उनको ढूंढ के हमको लाना है और हमको छोटे छोटे ब्लॉक्स में एटलीस्ट अगर उनको हम देते हैं तो हम लोग ये सब मिनरल को एक्सकैवेट कर सकते हैं, हमारे नेशन के लिए हम लोग इकोनॉमी डेवलप कर सकते हैं। थैंक यू।
If anyone has any question?
Hello.
Check. As you told,
हाँ, बोलिए।
that critical minerals are occurring in pegmatite bodies.
Pegmatite bodies. Yeah.
So there is one mineral known as
Hello.
tourmaline.
These all number of pegmatite, the all pegmatites are tourmaline bearing.
Yes.
Yeah.
What is the use of tourmaline?
Yeah.
And the state government granting the lease of quartz for mica.
Okay.
But associate mineral are tourmaline.
Okay.
And in absence of non-grant or knowledge of the state government officers or the mine owner,
Okay.
they are using as a waste, and the people are exporting on the
Yes,
name
yes,
of
yes, yes.
valuable minerals.
Yeah, boron bearing. This tourmaline,
Also-
they are all boron bearing.
Is that pegmatite body having kyanite? I have observed it.
Okay, okay. It's
And
good.
that
In
kyanite
India,
was
India
used-
itself.
It was very high grade kyanite.
Where is there? Where is it?
More than, huh?
Where it is?
In Rajasthan.
Okay, okay.
Rajasthan is famous for pegmatite bodies.
Yeah, yeah. Aravali, yeah.
So there is like beryl, titanium,
Yeah.
and
नहीं, इसमें एक चीज़ क्या है सर, इसमें एक्सट्रैक्टेबल क्वांटिटी पे होना चाहिए, बिकॉज ऑल टूरमेलिन बेरिंग पिगमेटाइट्स अगर हम लोग जाते हैं भंडारा में, जाते हैं मंसर फॉर्मेशन में, हम लोग कांदरी, कातुरबाई, ये मैंगनीज बेल्ट में,
इस पे आ जाइए ना।
mine owner is not knowing.
इस पे आ जाइए so that it will be there.
If mine owner is not knowing, he is using it as a road material.
हाँ, hello.
Huh? Then
Hello.
who will take care of? GSI is not reported. MECL is not reported. State DGM geological wing has not reported. But if I observe,
अब सर ऐसा है कि कल हम लोग को सीजी सर ने बोला कि अकेला चना ध्यान नहीं फोड़ता, तो इस प्रकार से क्या है कि ये एक्टिविटी सबको देखना है कि अगर ये वैल्यूएबल है हमारे इंडिया के लिए और काफ़ी बड़ा टूरमेलिन क्रिस्टल मिल रहा है और ये सब है, तो इसको रिपोर्टिंग करना चाहिए।
whose deposit of tourmaline was there in Jawar, now district?
Yeah.
It was passive
Exactly.
of Ajmer district,
Yeah.
Rajasthan. And when I observed that deposit, it was a huge dump, you can say.
Okay.
And 5 years back when I went that side, it was completely vast. There was no.
ये सब केयर तो अभी लोकल स्टेट गवर्नमेंट को करना चाहिए। ये स्टेट
वो बोलते तो हाथ में ऐसे हो जाता ना। मैं जब हाथ में
तो
आदत नहीं वही करी।
ये राजस्थान गवर्नमेंट का प्रॉपर्टी है, उनको उसका केयर करना चाहिए।
मैं ये बोल रहा हूँ प्रॉपर्टी
हाँ,
प्रॉपर्टी जैसे आप बताया,
Yeah.
ठीक है,
Okay.
आपने देखा,
Okay.
but he is not knowing, he has never visited, he has never read anything,
Okay.
not reported by GSI, MECL, state government and all these things. And if I know, I went there, no other IBM officer went there.
Okay.
How they can say it was a tourmaline or it was
Exactly.
kyanite or all these things.
Yeah, yeah.
And it is my observation
Mm-hmm.
that these minerals are in particular pigmented bodies.
Yeah.
They are in the form of anticline, syncline.
Okay.
If you calculate the distance or axis of these pigmented bodies,
Yeah.
you will find the mineral.
Okay, yeah.
That particular.
Definitely, definitely.
But observation is most important than the particular drilling and exploration and all these things.
Yeah, sure. The similar case is there in Bastar.
Ah.
Bastar, the local tribals, what they are doing, they know cassiterite. They don't know the value of that cassiterite and other niobium, tantalum and lithium and all that. Since long back, 2-3 decades, what they are doing in the night time, they are digging, they are finding gravel zone. They are very smart. They know ancient slopes. So along the ancient slopes, they know where is gravel zone is. Because it is brittle, it is broken and it is rolled on the ancient slopes and it is deposited in that gravel zone. So they pan that gravel zone.
My question is that
take out.
we are talking all these mineral, critical mineral, and we are seeing at foreign countries in also.
Yeah.
But what is there in our own country, we are not knowing.
मैं तो वही बोल रहा सर, हमारे देश में भी है, हमारे यहाँ पर खाना तैयार है, हमको थाली में समझना। हमारा छत्तीसगढ़ और जो ये 80 किलोमीटर का बेल्ट है, ये बेल्ट 80 किलोमीटर में हम लोग 10 कंपनी को वहाँ उतार सकते हैं, इतना पिगमेटाइट है।
पूरा अरावली भरा पड़ा है।
और अभी हम लोग ये स्टेज पे खड़े हैं कि अभी हमारा G4 लेवल का वहाँ पर शायद कोई।
मैं अपना ऑब्जर्वेशन बता रहा हूँ। I am not a geologist, mining engineer.
Yeah.
If you study the occurrence of plantation in that area, you can find the percentage of that mineral also.
Yeah.
That I observed in bauxite mining, China clay, ball clay, and you will find the alumina content in those species.
Geobotanical studies.
Ah,
Okay,
geobotany.
fantastic. Thank you.
But it is not read
Yeah.
any people, mining or geologists.
It has to be taken care of.
Well, sir, thank you for the question.
Okay.
Actually, as you all know, critical minerals in India, it is at a very, very nascent stage. इससे पहले the entire focus was on bulk commodities. Maybe last 3-4 years, we are thinking of critical minerals.
Exactly.
So once you start thinking about something, then you start implementing it in the field. Because you have seen the tourmaline maybe 20 years back, but nothing happened at that point of time because no one was interested in tourmaline at that point of time. But now the interest has happened and people are looking at it. Sir, वो तो that is a process in itself. उसमें कुछ कर नहीं सकते. But अभी धीरे-धीरे people are looking at it. A lot of activities are going on. Lot of exploration is going on. I think so. So शनवाने साहब जो बोले, actually एक question मेरे उनको था, specific question था. Who talked about Hamco. Hamco was having some pilot plant or plant.
Exactly. Palong. That is called Palong.
Yeah, but why did they stop that plant? What
Because of some government policies. All that because of government policies. The company has stopped because already we had we had taken out near about 300 to 400 tons of cassiterite, niobium, tantalum, lithium also. And one more important thing in that area, if anybody will go for mining, their mining cost will be nil because the Kolab River, the rivers is there that during our study we have done 2,000 number of pits there, and we have find out the gravel zones and ancient slopes, and what we find that whole area, the river is migrated for 75 kilometers. So in whole area the gravel zone contains gold, placer gold. So that will make the mining cost totally zero.
Senwai sir, you have worked in that project, na? You have
Yeah,
worked in that.
I was there.
And you had a lease there also. Hamco had a lease.
Yes, Hamco had a lease.
What was the policy? I don't know. What was the change in policy of the government? Why you stopped mining and?
That's that I don't know because why Orissa government or government of India or government of Madhya Pradesh they have stopped that company, or might be some fraud has been done by the company because it was from Dubai.
Okay.
ना the company was multinational.
Dubai based company.
Yeah. Okay. Thank you sir.
सतीश जी एक सवाल था मेरा, ये J&K में रईसी डिस्ट्रिक्ट के अंदर जो लिथियम का बहुत बड़ा डिपॉजिट मिला,
बिल्कुल सर, बिल्कुल,
वो आपकी फर्स्ट स्लाइड में कहीं आपने शामिल नहीं किया।
ऐसा है कि सर मेरे को तो स्कोप नहीं मिला, लेकिन इसमें बोलना नहीं चाहता, लेकिन फिर भी मैं बोलता हूँ। मैं ऐसा है कि सीनियर्स ऑफिसर्स के साथ मिला, उनको बोला आपने तो बहुत बड़ा भंडार ढूंढ लिया इंडिया के लिए, अभी तो हम लोग बिल्कुल नंबर 1 लिस्ट में आ जाएंगे, लेकिन अनफॉर्चुनेटली जिस जियोलॉजिस्ट से और जिनसे मैंने बात किया उन्होंने कभी लिथियम देखा ही नहीं। सो अभी मैं इसके ऊपर क्या कमेंट करूँ, मेरे को आई डोंट नो।
थैंक यू सेना साहब।
हाँ बोलिए सर।
एक मिनट।
I just listening to this conversation and I'm thinking
We are talking about critical minerals and we have a wealth of information already, anecdotal information. Can we have a group under the NCCM which is going to get all this anecdotal information together, put it all together and then create a map? Because the information, the information and experience that you have had, Goel Saab, and the experience that you have had, there are many geologists like that all over the country. If you get all that information together and make a national database. Thank you.
Thank you, sir. Thank you.
Rightly said, sir. The knowledge, the experience what Mr. Shenwai is having was really remarkable, and the experience what he had shared in this platform, it was eye-opener for us also, and also eye-opener that none of the project has been executed or neither mining has been started. And what rightly said, all the like-minded people who are well-versed with this critical mineral deposit should come on one platform and explore for the best of our country. Thank you. Thanks, Shenoy Saab, for sharing your valuable inputs.
We'll call our next speaker, Ms. Kritika Jangle, to present on sustainable lithium supply through secondary extraction technologies.
Good morning, respected dignitaries, research person and industry person present here. I am Kritika Jangle from Department of Geology, Nagpur University. I am here to thankful to giving me this opportunity to present my review-based topic, sustainable lithium supply through secondary extraction technology. So these are the content of my topic. So currently, lithium is not just a lightest material, it is becoming the foundation of green energy, electronic vehicle and energy storage sector. According to International Energy Agency, global lithium demand will grow 4 to 5 times by 2030. India, being a third largest consumer of energy, will face urgent need for lithium, but we are almost depend on import of it. So at the same time, global lithium prices are volatile with market and geopolitics. So we need to try for stable foundation for lithium mining, or say beyond it by using urban mining, using waste product. So currently, as we all know that in 2023, GSI discovered nearly 5.9 million tons of lithium bearing ore near Shalal, Haimana at Jammu Kashmir. But these clay host deposits, which are geologically challenging and require advanced hydrometallurgical processing, as of now, India does not produce lithium in a domestic mine. So before going to secondary extraction, we need to first know which are the primary sources of lithium. So lithium primarily occurs in the 3 types, like pegmatites, which is also known as a hard rock deposit, brine reservoir, and sedimentary clay deposit. So as seen in this image, the most common hard rock source is spodumene bearing pegmatite, formed during final stage of magma crystallization when lithium become concentrated in a residual silica rich melt. And in case of lithium brine deposit, on other hand, are found in closed basin evaporites environment, particularly in lithium triangle of South America, which generally include Argentina, Bolivia and Chile. And these brine form through weathering of lithium rich volcanic rock, where lithium is transported by the groundwater into salt flat and enriched through evaporation. The lastly, sedimentary clay deposits such as hectorite clay occur in lacustrine or lake beds environment and form through weathering and alteration of volcanic ash or tuff, leading to lithium incorporation within clay mineral. Each deposit type require distinct extraction approaches and present unique economic and environmental challenges. So these are some conventional techniques of extraction, while in case of extraction technique used in clay deposit, countries like China, Germany and Czech Republic are advancing lithium extraction from mica-rich clay deposits, especially from lithium micas like lepidolite and zinnwaldite, while full-scale commercial production is still limited, and pilot project and semi-industrial processing units using roasting and acid leaching are underway, with China leading in technological trials. So now, what are the national strategy? Indian government classified lithium as a critical mineral in 2023, and critical mineral mission allowed to build exploration and processing with budget of nearly 34,300 crores over 7 years. Also in Sitarganj, commercial recycling plant were developed for lithium extraction through partnership of Remain India and Technological Development Board. Also, Kabil to Peckert means Khanij Videsh India Limited took effort in international partnership with Argentina and Australia to secure long-term supply of lithium, showing step of India from moving policy to action mode. So, why secondary sources are required? There is rapid demand of lithium in electronic and energy storage sector, but India has very limited lithium reserve. Growing e-waste reserve arise a concern of pollution, especially the e-waste pollution, and need recycling. So, with battery extraction or the secondary sources of e-waste is the only recycling technique which is clean alternative for secondary sources and also reduces environmental impact. So these are some secondary sources where used battery, battery scrap, black mass or e-waste and EV waste are generally shown in a green color, which show the green signal to the extraction or recycling technique for lithium. And where the red colored boxes like which containing fly ash and oil-filled brine, geothermal brine are under exploration and research study. And the last three are limited to lab only. So lithium-ion battery, which is one of the proven secondary source, it contains lithium bearing component found in cathode and electrolyte, while anode contains graphite and microsphere, which reversibly absorb and release lithium. So recycling lithium from used lithium battery involve multiple steps, which safely recover the valuable metal like lithium, cobalt, nickel and manganese. So this process begins with the mechanical dismantling of batteries to separate components such as casing, cathode and anode and electrolyte. This includes following steps such as dismantling, crushing and shredding, side reduction, sorting, etc., which also increase the surface area for further processes. So these are some extraction techniques. So these techniques are divided into three types: hydrometallurgy, pyrometallurgy and biometallurgy. So in case of hydrometallurgy, which generally include leaching with acid or followed by ion exchange or solvent extraction or membrane extraction technology. In leaching, acid or base or some solvent is used to selectively extract lithium, while in ion exchange, appropriate resin is used to select, which has some selected functional group which absorb that lithium on their surface. So this resin selectively absorb lithium from that solvent or pregnant leachate solution. So in case of solvent extraction method, lithium is extracted with two different phases of liquid by adding organic solvent, where lithium is extracted into the organic solvent. In case of pyrometallurgical process, e-waste is treated with high temperature smelting or reduction to get lithium, but patent line such as Umicore or Accurec is from the Germany and Belgium respectively are working as a recycling process, working on this recycling process where lithium is going into the slag. So again, we need the hydrometallurgical processes. So in case of biometallurgy, lithium extraction is still under progress because lithium is very rarely absorbed by the organic entity due to its large ion size. Sustainable lithium production, but before that, I want to share some cost prices which is given by the Neetam Industries. So, as per their report, from 1 ton of spent lithium batteries of lithium-ion batteries, about 10 to 50 kg of lithium can be recovered. Depending upon the battery chemistry, like MnC means nickel, magnesium, manganese and cobalt, or NCA, nickel, cobalt and aluminum oxide batteries, which generally found in a cathode, or LFP, which contain generally lithium ferrous phosphate. So these batteries generally NMC and NCA batteries yield higher lithium, which generally up to 5%, and then LFP, which is a lithium ferrous phosphate type. Using hydrometallurgical recycling, recovery efficiency can reach 90 to 95% of recovery, and recycling cost per ton in India is roughly nearly 60,000 to 1,50,000 rupees, but recovered metal will help to offset this. With lithium, prices around 1,500 to 2,000 per kg, recycling can be economically viable and sustainable. So back to sustainable lithium production. Sustainable lithium production from secondary sources emphasizes recycling of spent lithium battery using environment-friendly methods like hydrometallurgy, which uses less energy and generate minimal emissions. And sustainable practices also prioritize water conservation, reduce land disturbances, and sourcing from secondary material to support a circular economy and reduce dependency on incentive mining. So future perspective of India showing India is increasingly embracing secondary lithium resources as a demand for lithium-ion batteries surges, which with strong government support for electric mobility and sustainability, lithium initiatives are gaining momentum, and advancement in battery recycling technology are making lithium recovery more efficient and cost effective. Global trend towards circular economy model and sustainable resource management are also influencing India approach, positioning secondary lithium as a key pillar for the greener and self-reliant future. So back to the conclusion, India's lithium demand is rising rapidly due to EVs, energy storage and electronics. RIAC at Jammu and Kashmir deposit is promising but faces challenges, which is micro-hosted clay, seismic zone and environmental sensitivity. Secondary resources like spent alloy-ion batteries offer faster and eco-friendly and scalable solution. Hydrometallurgy technique like Neetam at Loham enable efficient recovery of lithium and other metals. So global petting method, which is done by the USA, China and Europe, provide model for the advanced recycling and extraction technique. So India must combine domestic exploration, international collaboration and strong recycling infrastructure. These are the references of my topic. Thank you.
Do we have questions for Ms. Kritika?
I've got it. बड़ा interesting मैं बता रहा हूँ. I've had I attended a seminar in Delhi on lithium. तो lithium सुन के सब कान में घबरा जाता है. तो मैं क्या किया? बैटरी वालों को पास गया यार, तुम बैटरी दो. अराउंड 20-25 बैटरी लेके आया और हम लोग का टेबल में एक तो ग्लास रहता मोटा वाला हमारा HOD माइनिंग है डॉक्टर मिश्रा, हम एक को खोला, मैं बच गया, अदरवाइज आई वुड हैव बीन बंट। प्लीज ये सब मत करिए, बड़ा डेंजरस है। लिथियम को खोला, पेपर 2 फोल्ड पेपर में और लिथियम कहीं के छुपा छुपा के रखा है। मैं जैसे खोला फटाक से आग निकला। सो मैं इसका SOP फिर बाद में लकीली वहाँ पानी में लाके उसको डुबा, पानी में इसको खिसकाया, उसके बाद उसका SOP पढ़ा। SOP क्या है कि आप नमक का घोल बनाइए और लिथियम बैटरी को सबको डालिए तो उसका जान खत्म हो जाता है। उसका बाद थोड़ा हिम्मत आया, 20 किलो बैटरी खरीदा 20 किलो खरीद को उसको पानी में डुबा के रखा। अभी 2-3 महीना से इसको शांत करके रखा हूँ, उसको IIT पटना भेजना है। तो मैं बता रहा हूँ लिथियम, पर एक चीज़ अच्छा है इसमें हाथ डालने से, एक अच्छा चीज़ सीखा कि पहले SOP पढ़ो, सेफ्टी पढ़ो, उसके बाद ये सब धंधा करो, नहीं तो जल्द जुल जाओगे। थैंक यू वेरी मच।
Thank you, Ms. Kritika. Now I invite Dr. Anup Shukla, who will give his presentation on emerging technologies in critical mineral recovery from tailings and mine waste.
Good afternoon, everyone. Going with the theme of this seminar, I'll be presenting emerging technologies in critical mineral recovery from tailings and mine waste. As we all know that critical minerals have suddenly become very important. The industry was actually caught off guard because China was developing everything and the rest of the world was lagging behind. So right now the minerals which have global supply chain risk and they are crucial for green technologies, they are classified as critical minerals. So every country has set up its sustainable development goal and it's green technology, and green technology requires critical mineral for their production. So as we have seen in previous presentations, we require many times more critical minerals for green technologies as compared to conventional technologies. Now this figure demonstrates that conventional minerals such as cobalt, copper, nickel, rare earth, these are actually the production. Extraction is not dominated by one country, but the production part, if we look at the production part, all are dominated by China. Copper, nickel, cobalt, lithium, and rare earth even more so. So this poses a very significant geopolitical supply risk, and we need to address it by mining or by extraction of critical minerals in mine waste. So globally we have around 282 billion tons of tailings, and in our project, in Malaysian Copper project, we have around 80 million tons of tailings. And that tailings are rich in molybdenum. We have about 400 ppm of molybdenum, and we have about 800 ppm of copper, 0.08% copper. We have gold also in the tailings. So this extraction will serve as dual benefit of resource recovery and environmental remediation. Now, overview of technologies. We have various technologies available, and I should share that all these technologies are basically in developing stage or in experimental stage. So which of this will eventually be successful, only time will tell, but I'll highlight all of the technologies. First, we will go with the bioleaching. So bioleaching, as the name indicates, what happens when we attack chalcopyrite, in case of copper, CuFeS2, that copper reacts with sulfuric acid or any acidic leaching, and it forms a passivation layer of elemental sulfur. And that sulfur covers up the new surface, and it prohibits the further leaching of chalcopyrite with acid. So what the bacteria AF, acidothiophilus ferrooxidans, what it does, it prevents the passivation and allows the reaction to go on till the completion. So, but the problem with this is bioleaching requires a very specific set of parameters so that bacteria can survive and can do its work. In Finland, they have conducted bioleaching studies, and they have recovered about 87% of cobalt, about 100% of zinc in the tailings, and 87% cobalt recovery was from bioleaching. But the process took about 10 to 15 days, about 21 days for completion of the reaction. So if we are going for bioleaching, we have to look out for our supply chain in such a way that this time factor is taken care of. Now moving on to hydrological innovation, we have all seen that we can go for acidic leaching, but with tailings, the problem was that the tailings are too fine and they need to be agglomerated so that the leaching process can start. So Antofagasta in Chile have developed a Cuprochlor-T technology, which is based on chloride-based heap leaching, and they have achieved over 70% copper recovery. But the time was very high; it was around 200 days for copper. Similar case studies are Australia, Cobalt Blue Holding. They have demonstrated this leaching technology, and they have recovered multi-metal recovery, including cobalt, copper. Both are critical for green energy. Another case is the Rio Tinto's Boron California project, and they are going for battery-grade boron and lithium for about 10 tons. They have launched a pilot project into 2021 and produced about 10 tons of lithium per year, and they are going for a full-scale 500 ton per year plant that is in pipeline. We have all heard of acidic leaching. So in acidic leaching, we require acidic inorganic acids such as sulfuric acid, hydrochloric acid, which have a pH of 2 and 3. But recently, people are investigating different researches being carried out for glycine leaching. Glycine is an amino acid, and it requires pH of 7 to 10, and it can effectively extract copper, gold, cobalt, and nickel. Similarly, with the similar process, we can go for other organic leachants such as citric acid, oxalic acid, and acetic acid. The advantage of these two are that they require near neutral pH, so there is no environmental problem of acidity, and these can be handled safely. On a commercial end, there is a project, Vindara Tailing Project in Australia. They are going for nickel and gold extraction from old tailings, and they completed a test work in 2021, and they have got pretty good gold and silver recovery, about 38% for gold and 31% for silver in the Vindara Tailing Project. On the nanotechnology application side, we have developed nanotechnology for capturing the rare earth element. So we use magnetic iron oxide nanoparticles, and these particles bind to the rare earth elements, and these are then magnetically separated from the solution. Similarly, with the few people have developed in 2024 nano-absorbents, nano-structured absorbents. These absorbents have a structure which can effectively capture the rare earth element. So they have a feature of high capacity and high selectivity for rare earth. So these can be effectively used for absorption of rare earth element out from the solution, and then it can be further extracted down the line. One other process is supercritical fluid extraction. This is also similar to leaching process. In this, high pressure CO2 with an organic extractant is added to the tailings, and then we leach out the metal from the tailings. We can see that after 10 to 15 hours, we can get about 70 to 80% gold recovery in this case. The experiment was conducted in 2022, both the experiment. So this is a part of biomining. So there are certain plants which are known as hyperaccumulator. They take up extraordinary concentration of metal in their tissues without poisoning themselves, and they are known as bio-ore. So there are over 700 plant species which can extract nickel from the soil, and there is a US company, American company, Metal Plant, which has set up an actual commercial setup in Albania. They are using these plants to mine nickel about 200 to 400 kg per hectare. This is actually equivalent to 1% of commercial nickel ore. So this has been very successful. And after that, what they do is that they burn out the plant and they extract the nickel from the plant. So this is actually biomining with hyperaccumulator plants. Now these are the plasma and microwave technologies. These are not actually extraction technologies, but this can actually help us to break down the lattice of tough minerals so that down the line during leaching process it can be extracted. So cold low temperature plasma for coal-based RE feedstock have significantly improved the leaching of RE. Similarly with the microwave can selectively and rapidly heat due to dielectric heating, and this can generate microfracture which can significantly increase the surface area of the reaction, and then it can further subject it to the leaching process, conventional leaching, and that can speed up the chemical kinetics of the leaching. And the advantage is they use less energy than conventional roasting. This is another pre-concentration step for chemical treatment. Sensor-based sorting, we can use X-ray and NIR sensors to sort out the mineral before subjecting it to the recovery process, before subjecting it to the leaching process. And X-ray sorting can actually increase the concentration of feed, which has been subjected to the leaching. And once the feed grade increases, the leachability of the material also increases. This is the diagram of X-ray sorting. So we can sort out the ore and waste, and we can enrich the tailing to further concentration of metal. In 2025, India has actually launched its first national tailing policy, and in Union Budget 25-26, the mine tailing, alumina waste, chromite overburden, and uranium tailings are being focused, and this is under a new national critical mineral mission with a total investment of 34,300 crores. India currently imports 100% of the lithium, and it must develop its own sources, and we have about 500+ million tons of tailing of identified mine waste. IBM and several other agencies are exploring the possibility of critical mineral extraction from tailing and other mineral waste. So in conclusion, we can say that we have till now considered tailings as a waste and as an environmental liability, but it can be seen with the proper use of technology, it can serve as an untapped source, and with the maturing of the technology, we will see much more success in extraction of critical minerals from mine waste. Thank you.
Shuklaji, my question is, what are the experiments you had shown? All were done in abroad.
Yes, sir.
Is there any experiment or any study done in our tailings? You told that lakhs of tons tailings are available in India.
Yes, sir.
So any such experiment has been conducted in India?
Sir, one extraction experiment, as far as I can remember, was done by IIMT in Bhubaneswar using tailings. So they were extracting molybdenum from that. But the recovery was, they are in iterative cycle, they are improving their recovery by hit and trial and different methods.
हेलो शुक्ला जी, एक सवाल मेरी तरफ से। आपने इमर्जिंग टेक्नोलॉजीज़ के बारे में बताया और माइन वेस्ट और टेलिंग के बारे में बताया।
सर,
जो बॉक्साइट माइंस हैं वहाँ से हमारे पास यहाँ ब्यूरो में प्रपोजल्स आए कि आप हमको इसको पिट जो माइंड आउट पिट उसके अंदर फिलिंग करने का परमिशन दीजिए। आई वॉज अगेंस्ट, बट लेटर ऑन इट परमिशन वॉज एक्सटेंडेड। सेकेंड, MOEF हैज़ इशूड ए सर्कुलर that they have to backfill the abandoned mine pits with fly ash. But recently we came to know that fly ash or bottom ash or red mud, it is a storehouse of critical minerals.
Critical minerals, yes, sir.
So what is your opinion in that?
Sir, I think we have to come up with like a tailings, like we have this mine closure plan, we must have a tailings or mine waste reclamation plan added to the mine plan of the via IBM, so that before subjecting it to considering it as a waste and filling it into the mines again for abandoned mines, we can have some sort of experiment or some sort of filtering process done chemically, so that we can, before discarding it, we can see if there is something present there, extractable or not.
It is already established
Yes,
that
sir.
red mud and
Red mud,
fly
yes,
ash
sir.
is storehouse
Yes,
of
sir.
critical
Yes, sir.
minerals.
But for this chalcopyrite tailings and other tailings, we need to develop some sort of process so that we can categorize the tailings into whether they can be filled completely or some percentage can be subjected to leaching and some can be filled. Yes. It is currently off the table, sir. Yes. Yeah.
Hello. As all the process that you have been shown for the extracting of the rare earth mineral is
Yes.
always being, that leaching. And then leaching is, I think so, cannot be get processed after adding all those acidic material into this. So after the, extracting of the minerals and everything, the waste is also being generating. So what will after that? Means how do you get disposed or how do you get, utilized? Because after the using of arsenic and other acids, it is very, very difficult to get disposed it.
Yeah, that can be disposed in abandoned mines. This is what I was telling, that
No.
before discarding it to the, before discarding tailings as it is into the mine, we can run some sort of chemical experiment on them so that we can decide whether the tailings are actually useless or they contain something. If they are actually useless, that can be sent for backfilling, and if they have something, we can extract the metal, and then whatever silica remains, that silica can be recycled back to the abandoned mines.
So if you dispose into the earth and after some time there is the adverse effect of the earth also. That is the being part of the maybe that covered and what is the happening or what is the doing in the other organization to be get disposed that waste should not be get disposed onto the earth and should not be throwing out in the other place. That should be get covered maybe.
Yeah, actually, we can have a policy on that. It's too early to say that, sir.
Oh, just to get to have case study for the other country what has been doing before implementing into the India.
Yes.
Because one of the another process that we have been working on is the biomining, if you know about that. It is still 25 years ago that the project has been started, but it's still not been conquered. What we have to do after the biomining.
Sir, actually, this is a very hit and trial method. So tailings was a time it was considered as a waste. Total waste tailings. We were actually giving it away free to MOIL so that they can backfill their mines. But now with support from the government and policies, the tailings might become very useful in future.
Okay, thank you. But should we get a right narrative over there?
Yeah,
to
yeah,
get this
exactly,
part?
exactly.
Thank you very much.
शुक्ला सर, मेरा एक छोटा सा सवाल है आपको।
सर।
आपने प्रेजेंटेशन शुरू किया, आपने पहले बताया कि हमारा कपर माइन में, हमारा टेलिंग्स में बहुत सारे रेयर मेटल्स, क्रिटिकल मिनरल्स, क्रिटिकल
Yes,
एलिमेंट्स हैं। Then you switched over your topic to what is happening around the world.
Yes.
But you didn't speak what you are doing. What R&D activities HCL as a company is doing to see whether any recovery is possible from their tailings or not. Have they done any tie-up with any research organization or with an academic institute
Yeah.
to understand whether their tailings, anything can be recovered from their tailings or not?
Sir,
That you didn't speak about. Actually, you should have spoken about that.
Yes,
But
sir, we have-
HCL as a company,
Yes.
because you are a company of more than 50 years legacy.
Yes, sir.
So you should now start saying what actually HCL is doing in that front. And I think so in the morning hour somebody said कि भाई instead of regulations we should have self-compliances.
Yes.
So what HCL is doing towards self-compliances, not only HCL, there are many other companies.
companies also.
So are they doing anything themselves to show that yes, we can recover the critical minerals from the tailings or from the process itself?
Yes, sir. Sir, we have actually awarded a contract to Macon for analysis. We are in analysis phase. So we are sending our samples to Macon. Just 1 or 2 months back, we have started the project. And let's see what the results are, sir. So molybdenum, they have given that molybdenum is 400 ppm in Malaysian tailings.
Macon is not a company who specializes in R&D studies of recovery of critical elements or minerals. They are basically
Yes,
a
sir.
consultancy
Consultancy.
organization जो
Yes,
कि
sir.
erections and ये उसमें काम करते हैं. So we should be actually having tie-ups with various academic institutions or R&D organizations like maybe NML or IMMT or maybe even IBM, and come out with some solutions.
Yes, sir.
What you have said is that there should be a policy on something. Only when there is a policy, then we will be implementing it. And now what you are doing is that you know very well that there are critical elements in your telling, and you have started doing the paste filling of the same material into your mind. So ultimately what is happening is that the waste, the tellings which is containing critical elements is going back to your mind as paste filling, which will never be again recovered. So what are we doing on that front?
Yes, sir. We have a project with Animal regarding that. So if something comes up, that will be updated, sir. Sir, that. Yes, sir. Okay, sir. Thank you.
Thank you, Dr. Shukla. It's time for our last speaker, Mr. Prateek Godbole, who will present on critical mineral scenario of India in 2025.
Good afternoon, respected dignitaries on the dais and off the dais. I am Prateek Godbole from Department of Geology, RTM Nagpur University, and I am privileged to present this collaborative study on critical minerals of India 2025, geopolitical risk, domestic challenges, and a path to self-reliance. This is a review paper formulated by me along with my colleague, Ms. Tejal Nirvan, and my mentors, Professor K.R. Randive, Professor M.L. Dora, and Dr. Sanjeevani Zawdan. This review aims to shed light on the critical mineral landscape of India, which is framed within global transitions, strategic vulnerabilities, and domestic imperatives. It is now widely acknowledged that the global energy transition is inextricably tied to the availability and accessibility of specific non-fuel mineral resources, collectively referred to as critical minerals. These include cobalt, lithium, REDs, and others that are fundamental to technologies such as batteries, solar panels, wind turbines, defense, electronics, and also in medical and biomedical sciences. In this context, the adage that is given that there is no green future without critical minerals is not merely a slogan. It encapsulates the geoeconomic truth of our time. The decarbonization agenda must therefore be matched by a robust mineral security strategy. This is the framework of my presentation. Introduction. Critical minerals are essentially building blocks of various sectors. Lithium, cobalt, and REDs are indispensable and have widespread applicability. The problem is that the supply chains of these minerals are concentrated in a few countries, creating global dependencies. India is heavily reliant on imports, making it vulnerable to geopolitical and market risk. Therefore, developing a secure and self-reliant ecosystem for critical minerals is crucial for India's strategic and economic future. In this presentation, I'll explore the global and Indian scenarios, identify the key challenges, and propose a roadmap for resilience and growth in this vital sector. To develop this paper, we use both a qualitative as well as a quantitative methodology. As this review was formulated, we have used different web sources and reports from various government organizations and peer-reviewed papers. And the analysis that you can see on the screen right now is a keyword analysis that was adopted and developed using the keywords from which were available using different papers, and to understand what are the current trends and what are the clusters in the critical market scenario. Talking about the global scenario in general, the demand for key energy minerals continued to grow strongly in 2024. Despite this growth, supply increases, particularly from China, Indonesia, and the Democratic Republic of the Congo, have put downward pressures on the prices, especially for battery metals. Investment decisions are facing market uncertainties. Diversification is essential for energy security, but the critical minerals world has moved in the opposite direction in recent years, particularly in refining and processing. Today's market may appear well supplied, but export restrictions and risk to supply security are proliferating. Major risk areas include high supply chain concentration, price volatility, and byproduct dependency. The global need. This graph is about the demand of critical minerals, which has maintained a robust growth in 2024, supported by robust energy technology deployment. And this graph is about the global production of battery metals and REDs in 2024. This map gives us a visual representation of the worldwide distribution of critical minerals, which highlights that there are very specific geographical localities which are having the monopoly of these resources. This is the data that has been taken from the USGS, updated till 2024, and I have tried to plot all the 30 critical minerals to understand that which are the major players in this area. So graphs of all 30 critical minerals which has been identified by India are provided. Then, looking at the Indian scenario of critical minerals, the country is actively investing in exploring and acquiring critical mineral assets in resource-rich countries. Kabil, that is Khanij Bidesh India Limited, is playing a crucial role, having signed agreements with Argentina for lithium exploration. Kabil has also partnered with the Critical Mineral Office, CMO, in Australia. Due diligence is underway for selecting lithium and cobalt projects in Australia and strategic investment through offtake arrangements. In the context of how India adopted the critical minerals, a committee was appointed by the Ministry of Mines, which adopted a 3-stage assessment policy for the identification of critical minerals. In order to identify them, the Ministry of Mines committee adopted, and the 3 criteria were that reviewing critical mineral strategies, where major economies have already identified 69 critical minerals for future initiatives, with key studies by CSEP and CEEW, interministerial consultation. Ministries such as power, atomic energy, renewable energy, and other government departments have identified minerals critical to their sectors. Evaluating mineral criticality, an empirical formula was developed for evaluating the mineral criticality, which was derived after consultation with the IEA. So this was the basic formula, which was dependent on the economic importance and supply risk, which overall brings the criticality to these minerals. And there were 2 main criteria which were taken into account along with the economic importance, which were the import dependency as well as the supply risk. The geopolitical risks. India faces several geopolitical risks in securing critical minerals. Heavy import dependence makes India vulnerable to supply disruptions. China's dominance in global refining creates risk of price manipulation. Export restrictions by countries like China and the DRC highlight the fragility of the access. Global trade tensions can fragment supply chains. Limited African presence puts India at a disadvantage compared to China, which has a stronger geopolitical influence on the region. The domestic challenges. Domestically, India is facing several challenges. For example, limited geological exploration means the extent of mineral resources are not fully known. Lack of processing infrastructure forces continued reliance on imports for value-added products. Regulatory and land acquisition hurdles slow down the project development. An underdeveloped recycling ecosystem limits the potential for the circular economy. And low private sector investment due to high capital risk and lack of initiatives is also becoming an emerging problem. To cater this, the Government of India launched the National Critical Mineral Mission, NCMM, in 2025 to address these challenges and promote self-reliance. According to NCMM, the Geological Survey of India, GSI, will undertake 1,200 exploration projects between 2024-25 and 2030-31. The mission aims to secure India's critical mineral supply chain through both domestic exploration and strategic foreign partnerships. It also focuses on strengthening critical mineral value chains by enhancing the technological, regulatory, and financial ecosystem. India aims to cut emission intensity of GDP by 45% by 2030, source 50% of its power from non-fossil fuels by 2030, and reach net zero by 2070. These were the main objectives of the National Critical Mineral Mission. The components, critical minerals of the Indian industry sector. Critical minerals as identified by the India were 17 and have been vital to secure a steady supply chain of these minerals. The Ministry of Mines is establishing a joint venture, reduce import dependency by partnering with mineral-rich regions, and countries like Australia and nations in Africa and South America are leveraging India's expertise in exploration. In renewable energy, minerals like cobalt, nickel, lithium are fundamental for battery production, which supports India's renewable energy initiatives. Role of AI in critical minerals. Artificial intelligence offers significant potential in the critical mineral sector. AI can enhance exploration by analyzing geological data to identify areas with high potential. AI can optimize drilling and blasting operations to minimize waste and improve ore recovery. AI-driven process control can enhance efficiency in the separation and refining of the critical minerals. The main objectives of implementing AI in critical minerals could be to identify new potential areas for the exploration, to focus on finding hidden and deep-seated mineralized zones, to develop AI and ML algorithms that can clean, combine, model, and validate different types of geoscientific data, and to produce mineral predictive maps that highlight exploration targets. What are the current challenges and policy measures for India's critical mineral sector? India's critical mineral sector faces several challenges and policy measures to overcome those. For example, the regulatory challenges could be simplifying regulations, implement single window clearance, and streamline approvals to boost investment in environmental and social sectors. It can create balanced regulations, enhance community engagement, and ensure fair compensation for social acceptance of supply chain and security, promoting domestic exploration and production with incentives, and to establish strategic reserves for supply security in the market of investment and technological sectors. Also, we can offer tax breaks and subsidies to attract investments and increase R&D funding to drive innovation and efficiency. What are the current requirements for India? The current requirements for strengthening India's critical mineral sector are focused on upscaling exploration activities, exploring substitution of mineral and metal which can be imported, ensuring enhanced efforts towards the development of new technologies for conversion of existing mineral resources, import substitution, auctioning of one or more blocks for mining, encouraging recycling of metals, ensuring easy and abundant availability of mineral resources from domestic resources. Then the strategy and roadmap for India could be using optimal utilization of domestic mineral endowments and establish a national body responsible for sourcing minerals, of maybe a favorable policy regime and increase in research and development in mineral value chain, creation of knowledge network and promoting recycling, increase resource efficiency, amongst others. Based on the minerals which were classified by the Ministry of Mines, they were mainly categorized into 3 categories, which we have plotted here. That is, some minerals which were only having high economic importance, some based on supply risk, as well as some which were having both. Now, the relationship of critical minerals with sustainable development goals. This table illustrates the vital role of critical minerals playing in achieving United Nations Sustainable Development Goals. As you can see on the screen, the Ministry of Mines has outlined 3 criteria for determining the criticality of these minerals, focusing on 3 core dimensions. Based on their applicability, we have tried to correlate them with the SDGs, and there are certain goals which are more aligned as compared to the others, such as clean water and sanitation, SDG 6, where minerals like lithium and cobalt are essential for developing technologies used in water treatment, storage, and distribution for ensuring access to clean water for all. Affordable and clean energy, SDG 7, and climate action, SDG 13, where critical minerals form the backbone of clean energy technologies, such as solar panels, wind turbines, electric vehicles, and energy storage systems. These are crucial for India's transition to a low carbon economy and achieving its net zero emissions target by 2070. So, what are the reflections from this study? Several reflections can be emerged. For example, investing in overseas mineral assets and local processing to secure supplies and strengthen local refining, advanced market commitments, AMCs, to stabilize demand and encourage private sector investment, creating a critical mineral fund to support geological exploration and early stage projects, utilizing deep ocean mission to explore deep sea minerals and diversify supply, promoting recycling and circular economy through investments in recycling infrastructure and R&D, establishing a center of excellence for critical minerals to focus on advanced mineral discovery, forming a global cooperative mechanism to facilitate collaboration and resolve geopolitical conflicts. What could be the recommendations for India? Based on the review that we have made, we can say that India should expand exploration and fast-track 1,200 plus domestic exploration projects and auction identified blocks. They should also boost the processing, diversify imports, promote recycling, ease with regulations, support the investments, build reserves, strengthen CABIL, develop skills in R&D, and monitor global risk. Based on this, these would be the conclusions which will be emerging from the present study, that critical minerals are essential for India's clean energy, defense, and digital growth goals. India remains heavily dependent on imports, especially from geopolitically sensitive regions. Domestic challenges include limited exploration, lack of refining capacity, and regulatory delays. The National Critical Mineral Mission provides a strategic roadmap of self-reliance and global competitiveness. Strengthening partnerships, boosting domestic processing, and expanding recycling will be key to resilience. Rapid policy reforms, investment incentives, and AI-driven exploration are necessary to unlock India's critical mineral potential. Long-term security requires both national efforts and international cooperation aligned with sustainability goals. Thank you, sir.
Mr. Pratik,
Yes, sir.
very informative presentation and confidently presented too.
Thank you, sir.
Really hard work you had put, you and your team.
Thank you, sir.
Kudos to the entire team.
Thank you, sir.
Any
Thank you.
questions from the forum?
Thank you so much, Mr. Pratik. May I now please request Shri S.K. Adhikari and Shri Suresh Vandre to deliver their concluding remarks, please.
मंचासीन अधिकारी सर, काड़े सर, पुकरा साहब, गुजर साहब, सभी अधिकारीगण. First of all, I'd like to thank Kade sir and team for giving a wonderful opportunity to all the stalwarts bringing in one forum, and also the young brains to share their ideas, share their presentations in this esteemed gathering. The hard work what the young brains has put, it's really marvelous. The pain they had taken in gathering the information, presenting, it's really the hard work what they had done and their teachers has done. Thanks Kade sir and team for giving them the opportunity, and we as a seniors and stalwarts of this industry, we came together in one forum and shared our experiences. In this today's session, Mr. Shenwai, he has shared his experience of critical mineral exploration, and the best what he had gathered during his experience, during his field visit, he has shared in our forum, and we had enriched with his experience. Thanks, Mr. Shenwai ji. And Mr. Kritika Jangid, she had also nicely presented, and Dr. Shukla, no doubt his study, the what best they had done in abroad and all, many things has to be done in our own house. Though maximum presentation, maximum experiments were done abroad in the critical sector, what Mr. Shenwai has rightly said, सब कुछ है तैयार, हमको सिर्फ खाने की ज़रूरत है. तो the tailings what Hindustan Copper is having, the experiment they had to done, lot of study, lot of work we have to done for this critical minerals exploitation and exploration. And Mr. Pratik, really he has presented nicely with confidence, and in this tender age they are presenting their colleges, their papers in this forum. A long way has to go for them. Though they had taken the knowledge from the books, their journals, everything, maximum focus they now need is to go to the field and get maximum exposure from the stalwarts of this mining industry and give to the nation to the best extent possible. Thank you once again IBM team for giving us the opportunity to share this forum. Thank you, sir.
So thank you, Suresh sir, for the nice, basically concluding the entire session regarding what has happened during the session. But before that, I would like to thank the presenters. They all stuck to the time, dot time. I think so. None of the presentations were beyond 15 minutes. I think particularly the students, they rehearsed it very well so that they can present their presentation to the audience within a span of 15 minutes. And during the last 2 days, it is the first time we have been doing seminars off and on, but this is the first time I see that the overwhelming presentations were from the students community. There were presentations from industry, from the research organizations, but this is the first time we saw that I think so maximum number of presentations were from the students, particularly at RTM University. I would like to congratulate Randivesh sir, who has been sitting here since last 2 days with his students to see that the presentations are through. And they have really done a marvelous job. And coming back to whatever has been presented by the students, as I was a student maybe 30 years down the line, 1980s and 90, at that point of time what we were studying was only 10 or 12 minerals. As our Goel साहब said कि भाई टूर्मालिन भी मिलता है, उसको हम क्या करते हैं क्या नहीं करते, उसमें सही में बताएं तो उस टाइम पे 10-12 कमोडिटी छोड़ के बाकी दुनिया में हमारे इंडिया में कोई कमोडिटी के बारे में डिस्कशन ही नहीं होता था. ठीक है, तो this whatever is coming now, these critical minerals and all, this is a development of last 3 to 4 years. I think so in India, the first publication that came out regarding critical minerals was in 2013 or something. CEW had come out with a publication where they had listed some listed a list of minerals which could be declared as critical minerals. But government took maybe another 10 years. In 2023-24, we came out with our own list of critical minerals. So since then, the momentum has gained. Prior to that, there was no momentum in critical minerals. We never worked on that. Entire exploration activities were actually targeted towards bulk commodities. Even in 2015, we had a amendment in the Act. At that point of time also, the entire focus was the bulk commodities like iron ore, bauxite, chromite, or you can say manganese and all. So it is very baby steps that India is taking into the critical minerals sector. So to stabilize will require time, maybe another few years will be required. A lot of emphasis is being given by the government to do a lot of exploration. GSI has shifted its focus from bulk commodities to critical minerals. Almost it is 50% now. 50% of the deposits which are being explored by GSI is mostly critical minerals. Similarly, MECL and the NMET organizations, a lot of focus is there on critical minerals. But these greenfield projects to become successful and producing projects will take time. Definitely will be requiring another at least 10-15 years time to start really producing critical minerals in our country from the greenfield projects. So what is the focus now is that the brownfield ones, that is the tailings waste that is lying in our country. There were presentations here, two types of presentation. One is we are conserving our waste by doing backfilling and all. The other presentation was that there are a lot of critical minerals in the these mine waste. So we are at a crossroads as to what to do with our waste. Yesterday they were waste, but now today they are becoming slowly and slowly they are becoming very, very valuable commodities. So as Pukhraj Sahab just now told कि there are some MOEF guidelines that the bottom ash or the fly ash should be backfilled, should be reclaimed, and we are doing that. Actually, there were, I think so, there was a committee also, and in which Sarma Sahab was also there to how to utilize this bottom ash and fly ash. So a lot of things have happened over the years, but now time has again come to rethink, reorient ourselves to see whether we can really recover some critical minerals which are very, very valuable for our country, to see whether these waste which we consider as waste at some point of time because of maybe because of lack of knowledge, maybe because of lack of equipments, maybe because of lack of technology, that these were considered waste. But yesterday we had a presentation from our sir जो कि बताया कि भाई rock जो है एवरीथिंग इज ए मिनरल एंड हमारे लिए हर चीज़ इम्पोर्टेंट है. एंड मुझे लगता है कि वेस्ट जो हम जिसको कल तक वेस्ट मान रहे थे, जो टेलिंग्स हैं, हमारा रेड मड है, हमारा फ्लाई ऐश है, वो सब शायद कुछ साल के बाद वो हमारे लिए वेस्ट नहीं रहेंगे, वो सब हमारे लिए बहुत वैल्यूएबल कम्युनिटी बनने जा रहे हैं. बट वी आर पासिंग थ्रू ए phase of time when we are doing backfilling of these commodities, maybe in our mine pits, maybe in the infrastructure projects, but sooner or later there will be some rethinking and we'll be again going back and trying to look at these waste to recover the critical minerals. There was a point raised by Goel Sahab ki tourmaline is unavailable in pegmatites. Yes, I sir fully agree with you. as many of us have worked in Ajmer region, everyone knows that in the pegmatites or in the quartz feldspar mica mines, both tourmaline is also found and beryl is also found, that everyone knows. And fortunately or unfortunately, till now there was no focus, and as you all know, in our own classification of minerals, as per the regulations, we have minor minerals, we have major minerals, we have atomic minerals, and till now beryl was being treated as an atomic mineral. So we have taken a lot of efforts to ensure that beryl comes out of that category of atomic minerals to a separate category, that is the critical mineral. Similarly, we have brought out another 3-4 minerals, they have been done very recently. So there was a lot of issues were happening, because why people were not reporting beryl even if it was available in their mine. So there were issues because they were maybe they were afraid to report those beryl to the government, thinking that if today they report the beryl to the government, tomorrow the lease will not be theirs. So there were issues. So government is now trying to address each and every issue, and that is the reason why every now and then you see newer and newer amendments coming in our rules and regulations. So government is taking cognizance of whatever is happening around us, and based on that we are taking steps, and we hope that very soon there will be a much better environment, but much better climate to ensure that we are able to start producing critical minerals in our country. With these few words, I would thank again all the presenters who had presented very sincerely. They have prepared their presentations, particularly the students who had done a lot of research. They are more aware than us regarding the critical mineral scenario in the country, critical mineral scenario in the world. Even some student presented about Lohum. Lohum is doing a great work regarding recovering of critical minerals from the batteries and all. So thank you all that at least you are working on that, and government is taking a lot of steps, because every now and then you see that some seminar or something is happening on critical minerals. Just 1 month back we also had a seminar on critical minerals here in Nagpur. It was hosted by Government of India and Ministry of Mines and Indian Bureau of Mines. So आगे चल के शायद अगले महीने जो है एक जबलपुर में भी एक सेमिनार हो रहा है. It is being organized by GSI. So many things are happening, and let's hope that sooner or later we become actually producers of critical minerals and not importers of critical minerals. Thank you all.
Thank you so much, sir. Thank you for so beautifully summing up the session. For illuminating minds and sparking new conversations, we would like to felicitate the speakers. I request Shri S.K. Adhikari and Shri Suresh Vandre to kindly present memento to Mr. Satish Shenwai. With a warm round of applause, please welcome our speakers. I next invite Ms. Kritika Jangle. May I call upon stage Dr. Anup Shukla, please? And lastly, I invite Mr. Prateek Godbole. Thank you so much. At this moment, I'd like to convey our sincere thanks to Shri S.K. Adhikari and Shri Suresh Vandre for leading this session so eloquently and with a deep sense of purpose. May I please request Dr. Pukhraj Neniwal, Controller of Mines, Indian Bureau of Mines, to present memento to Shri S.K. Adhikari, Chief Mining Geologist, Indian Bureau of Mines, and Shri Suresh Vandre, General Manager, JK Cements. Let's have a gracious round of applause. Thank you so much. This brings us to the end of our last session. We'll have a short tea break, and in half an hour, I would request you to please reassemble for the valedictory session. Thank you. Welcome back, everyone. May I please request you to please be seated? We are starting with the valedictory session. Thank you. Each session, each voice, and each idea has added a valuable layer to our collective understanding of the mining sector's future. As we bring this vibrant exchange of ideas to a close, it's now time for the valedictory session. A moment to pause, reflect, and carry forward the key takeaways and spirit of collaboration that have defined the seminar. We are deeply honored to have amidst us distinguished dignitaries whose presence graces this valedictory session with meaning and inspiration. We have among us our chief guest, Shri Ajit Kumar Saxena, CMD MOIL. With a big round of applause, we welcome Shri Ajit Kumar Saxena. We also have among us Shri Piyush Narayan Sharma, Controller General, Indian Bureau of Mines, and Chairman, MEAI Nagpur Chapter. With a gracious round of applause, we welcome Shri Piyush Narayan Sharma. We also have with us our guest of honor, Shri I.D. Narayan, CMD, MECL. Let's give a big hand. It is my privilege to invite our distinguished dignitaries to the dais for the valedictory session. May I please request you all to please come forward and grace the stage. Let us now take a moment to acknowledge and formally welcome our honored guests to this valedictory session. May I please request Mrs. Jyoti Mathur and Shri G. Ram to offer our greetings to our chief guest, Shri Ajit Kumar Saxena, CMD MOIL. It is a privilege to welcome Shri Piyush Narayan Sharma, Controller General, Indian Bureau of Mines, and Chairman, MEAI Nagpur Chapter. I would once again request Mrs. Jyoti Mathur and Shri G. Ram to extend our warm welcome to Shri Piyush Narayan Sharma. We are privileged to have with us Shri I.D. Narayan, CMD MECL, and I request Mrs. Jyoti Mathur and Shri G. Ram to kindly welcome him. May I request Mrs. Jyoti Mathur and Shri G. Ram to extend our warm welcome. I would once again request Mrs. Jyoti Mathur and Shri G. Ram to extend welcome to Shri Piyush Narayan Sharma, Controller General, Indian Bureau of Mines, and Chairman, MEAI Nagpur Chapter. Thank you. As requested, I now invite on stage Dr. G.K. Pradhan, Dean, AKS University, Satna, to felicitate the dignitaries on dais. He's joined by HOD Mining, AKS University.
Mr. Pankaj Kulshesh is not here. I request Dr. Kale to receive on his behalf.
Thank you so much. We now move to a brief recapitulation of the seminar. May I now invite Shri Manish Mendiratta, Controller of Mines, Indian Bureau of Mines, and convener of the seminar to deliver a brief on the seminar proceedings.
Thank you, sir. Namaskar. And we are really happy to have you over here, sir. I will really would like to welcome Chief Guest Shri. Maybe, yeah. I think I'm audible now. Huh? So, my warm welcome once again to our Chief Guest, Shri Ajit Kumar Saxena Sahab, Chairman and Managing Director, MOIL, Shri Priyan Sharma Sahab, Controller General, Guest of Honor, Shri I.D. Narayan Sahab, on behalf of MEI. And sir, I've been given the honors to submit the brief on what happened in the last 2 days. And in the last 2 days, we had about 23 technical papers and 4 corporate presentations. We had very insightful discussions. And in the last 2 days, we have been deliberating on the issues significant to the mining industry. In the first session yesterday, we have deliberated on the present scenario and the future prospects of mining in India, with coverage on Jammu and Kashmir in particular. It had also had a detailed mineral review of graphite, along with a concise study of geopolitical limitations and the issues. Sir, the Lloyds envisioned a different perspective of BHQ mining and processing at Gadchiroli district. They had also given one presentation on the same. And the mining activities coordinated by the Lloyds at Gadchiroli is an epitome of new age mining. In the second session, we had presentations on legislative aspects of the mineral industry, which examined major legal reforms. Landmark Supreme Court judgment of MADA versus Steel Authority of India was discussed in detail, and it had been critically examined in the presentation, the limitations and the consequences of the landmark judgment. The author suggested to have a GST-like model in place to find the solutions for multiple tax regime through cooperative federalism. In this sequence, another author presented the paper on importance of mining, its role in GDP, and consequently suggested to name the areas lying with mine as mineral land, and also endorsed to designate IBM as a single window authority for all necessary approvals in turn. The paper on drone technology was also presented in the second session, and it explored the current applications in present mineral regulation framework and highlighted the challenges. It suggested for having a mining specific drone regulation and upskilling or capacity building in this field. In subsequent sessions, we have a case study on stoping methods for thick and wide ore body with weak and friable rock mass and complex geology supported by geotechnical studies, use of numerical stimulations, and modeling techniques and hydrological studies. We also had a comparison on overhead and underhead stoping sequence in underground mines with cemented paste fills and consequent recovery scenarios. A presentation on the geomechanical stability of crown pillars while transiting from open cast to underground in a chromite mine was also presented. There has also been a discussion on the importance as well as limitations of paste filling with thrust on economical parameters. In the first session on the second day today, we had a presentation on application of HPGR, that is high pressure grinding rolls, as an alternative economic solution for specific grinding needs of the mining industry. A diversified presentation on can space mining, a viable alternative, has been submitted as a food for thought, encompassing the challenges, governance issues, robotics applications, and sample analysis. Further, a presentation was also on the recovery of nanomaterials from mine waste, which is again a way forward to think differently. And in this concern, sir, there was one presentation on a relation between the specific charge and the fragment size. An idea has been floated for adoption of new drone technology for analysis of fragment size by the senior officers from the MEI. In the last 5th session, it was about sustainable mining technologies, where the best practices adopted in the mines have been highlighted by the author. It has also highlighted the importance of production capacities based on transportation capacity and dump size. We also had a wonderful submission and discussion on sustainable explosives used through latest technologies, electronic detonators, etc., and simultaneously stressed upon adhering to rules and regulations in this regard. The author also stressed upon the accidents that took place due to mobile and high frequency devices. Further, in the next presentation, the technical and biological reclamation concepts have been discussed for environmental sustainability and challenges for effective implementation. And in the final session, there are various aspects of critical minerals focusing on its importance in various sectors in renewable energy, and secondary extraction technologies too have been discussed. Recovery from tailing and waste and tailing waste and geopolitical issues too have been deliberated in detail. In the end, sir, I can say that finding the solutions from within the constraint, as you have said, was a key for the success of any seminar. We had a lot of issues, but the adoption of best practices and concerted efforts are the need of the hour, sir. Thank you, sir. Thank you.
Thank you so much, sir. It is now my privilege to introduce our esteemed guest of honor, Shri Indradev Narayan, Chairman cum Managing Director of MECL. He also serves as Director at Khanij Bidesh India Limited. His excellence has been recognized through prestigious awards such as Best General Manager and Best Planner by Coal India Limited. I request Shri I.D. Narayan to kindly enlighten the gathering with his thoughts.
A very good evening, dignitaries on the dais, Shri A.K. Saxena Sahab, CMD MOIL, Shri P.N. Sharma Sahab, CG IBM, dignitaries of the dais, Pradhan Sahab, Kale Sahab, and all other dignitaries and industry partners. For decades, the mining meant for what is hidden. Today, it also means the shaping what is possible. From exploration to transformation, the Indian mining is on the journey that goes far beyond the drill rigs and ore grades. It is about creating self-reliance, enabling clean energy, empowering regions and building the foundation for the tomorrow's economy. It is also an honor to be with this august gathering. I hope this national seminar of 2 days, where we all have reflected, reimagined, realigned our vision for the Indian mining future. The mining sector in India is currently at an important crossroads. From the traditionally regulated and resource-bound sector, it is now transforming into dynamic, technology-driven, and investment-attractive industry. The government's recent reforms, ranging from transparent auction regimes to liberalized FDI policy, have been the new energy and competitiveness into the sector. The private sector participation is growing, exploration is expanding, and the mining is becoming more scientific and more responsible. Yet, the challenges remain. Exploration depths, required infrastructure, and in the timely conversion of resources into reserves. Addressing this call for stronger synergy amongst all the stakeholders. The public sector undertakings like MECL plays a crucial role in shaping the future of India's mineral sector. We have been instrumental in discovering and proving reserves of nearly all major minerals across the India. Now we have gone beyond the Indian boundaries, and we are doing a lithium project in Argentina. We have signed an agreement with Catamarca province of Argentina for exploring the critical minerals there. There have been talks with Zambia. Zambia has recently given consent for offering a 9,000 square kilometer area of theirs for further exploration. We are also looking for some offtake of critical mineral from Australian land. So MECL has expanded its role, moving beyond the traditional drilling to adopt advanced exploration technology, data analysis, and remote sensing. We are now working as knowledge partner to both government and private players, delivering integrated geological solutions. In this decade of critical mineral demand and energy transition, MECL stands ready to support the nation's vision with speed, scale, and scientific precision. The Indian mining industry is undergoing a fundamental shift from mineral production to a more integrated value chain that includes exploration, beneficiation, processing, and end use. Today, sustainability, ESG compliance, digitization, and zero waste mining are no longer the aspirational terms. They are the operational imperatives. The new age technologies are becoming central to this transformation. Artificial intelligence, machine learning, remote sensing, and real-time data analysis are the reshaping how we discover, extract, and manage the mineral resources. At MECL, we are actively adopting these tools to enhance the mineral prospectivity modeling, improve drilling efficiency, and reduce exploration timelines. These innovations are not only drive productivity, but also ensures greater environmental and operational responsibility. In this evolving landscape that needs for better coordination across the mining value chain is more urgent than ever. Exploration, extraction, resource planning must work in concert, supported by digital platforms and collaborative institutions. That is how we can unlock the full potential of India's vast mineral wealth. The India's economic growth is fueling unprecedented demand for minerals, especially the energy transition, like lithium, cobalt, nickel, rare earth, graphite, etc. These are no longer the niche resources. They are the strategic asset for our clean energy and defense goals. Traditionally, our PSUs have been commodity specific, focusing on bulk minerals, coal, iron ore, lignite, etc. But this model is now evolving. Single commodity PSUs are strategically diversifying into critical minerals. Saxena sir is here. MOIL is actively involved in diversification, looking for critical minerals. A very encouraging trend is how even the monopolistic business of oil sector, even the oil industry is looking for critical mineral, because the critical mineral is the new oil in these days. From their expertise of deep-seated and how hard to reach mineral deposit, the convergence of expertise from oil and mineral sector is welcome step in building the national capacity for critical mineral exploration. The future of Indian mining will be driven by integration, innovation and inclusivity. We need a national mission mode approach towards the exploration with common data platform, a national geoscience alliance and coordinated project development. Our aim should be not only be resource mapping but the value creation, building downstream industries, generating local employment and reducing the import dependency. In the conclusion, I will like to say that the road ahead for the Indian mining is full of promise. But realizing this promise needs to be collective actions, long-term thinking, and spirit of partnership. MECL stands ready to play its part with commitment, capability, and confidence. Let us all work together to build the mining ecosystem that is productive, sustainable, and globally competitive. Thank you. Thank you so much.
Thank you so much for the insightful address, sir. We have as our chief guest Shri Ajit Kumar Saxena, Chairman cum Managing Director of MOIL Limited. He is also holding additional charge of Rashtriya Ispat Nigam Limited, Visakhapatnam. A distinguished alum of IIT BHU, Shri Saxena brings over 36 years of rich experience in the steel and mining sectors. Shri Saxena has been honored with awards such as the Global Indian of the Year 2023 and the CEO Business Leader of the Year. I request him to kindly share his thoughts and reflections with us.
Good evening, everyone. Before I address, thanks to the anchor lady making me 3 years younger, because the biodata is slightly old and the experience is now 39 years plus. So thank you. So good morning, good evening, everyone. My dignitaries on dais, my colleague Mr. P.N. Sharma, Mr. Indradev Singh, various dignitaries from academia, industry, and mining sector. Welcome to this valedictory section and a very good evening to all of you. Being in mining fraternities, it always mesmerizes me. The sessions start with geology, millions and thousands of years back, millions of years back. And it ends with environment, talking about future. So the kaleidoscope is very, very big. From millions of years to the years which we have not seen, which, for which we are designing and which we are talking about. And yes, that is the vibrance of this industry, and that is the comprehensiveness, the panoramic view of this industry, that it talks about millions, it talks about seconds. It talks about 70% ore, it talks about some few percent of uranium ore or something like that. So there's a very wide range. And that is why, earlier we used to say that resources are limited or time is limited or whatever we say. But the fact remains, even if resources are unlimited, none of us is allowed to waste it. None of us is allowed to waste it because it is not ours. It is something like a quotation very favorite to me. I always quote that this earth we have taken we have not inherited from our ancestors, but we have taken it on loan from our future generations. So we have to give it back to our future generations in a shape much better than what we have received. And perhaps that is the reason why all this sustainability, circular economy, circular economy and all those concepts. And that is the need, that is the call for all these kind of seminars which we attend. I can learn by my own mistakes, every organization can learn by their own mistakes, but then it will be a wastage of resources. And perhaps that is why these kind of seminars are needed. So in this, I would say that this chapter of National Engineers Association, Mining Engineers Association of India is very, very successful. They have time and again, they have done various seminars in 2017 against environment, 2018, and then another year, 2013. So at various times, whenever mining industry has given different call, Nagpur chapter has risen to the occasion and addressed those issues very effectively, very significantly. So my congratulations, my best wishes to them, even for this seminar, as well as in their future endeavors, because they are really rising to the occasion. And it is really difficult getting so many professionals to think over the future where the benefits are not immediate. Like nowadays, it is very difficult to get people. But this is the charm, or this is the real effort of this chapter, this organization, that so many persons have given their valuable time and interacting and sharing their knowledge pieces with their counterparts. So my best wishes and thanks to you from mining fraternity to this Mining Engineers Nagpur chapter. Various topics which Mr. Mendiratta recollected, and what Mr. Indradev Singh has spoken about the recent developments and recent advancements in the field of mining, as well as the achievements of MECL and the new fields and innovative ways of MECL. I would like to say that this is definitely a forum where we all have to learn from each other. And that is how we are saving our resources. And mining in fraternity, I would use the word, not industry, mining fraternity, I really feel so good that we are having in the same room from regulators, that is IBM, to DGMS, to academia, to practitioners. So this is really, this is the right and very comprehensive way of thinking about any sector. And all of us were here, so I am sure that very good deliberations have taken place. But I would like to add few things. One thing is that in any industry, in any corporate, when we do any HR program, we always take a feedback kind of thing, where after 6 months, how that individual who has been trained in a certain aspect, how he is doing, or what kind of projects he has taken. So I feel, being from addressing the mining fraternity, I would say that this should be, if not officially, at least informally, there should be a point that when we go back, we should have at least 2 points, 2 new points, which you think you have learned, and 1 or 2 points which you think and you should decide and you should come back after a few months that you have decided that you will be implementing in your area of work. So that when you come back next time, it is a continuation, it is a sequel of the last seminar, and you have, it is just not a drawing room talk or a coffee house talk. It is something which is reaching to its logical culmination. Maybe we have 10 ideas today. When you put it into practice, 7 may not be fruitful. So what happens? That we write down the successful one and we conveniently forget the ideas which have failed. And so again, next generation devotes its resources in working on those ideas and finding out the relevance or irrelevance of it. So I feel this should be logged, if not in a formal manner, on an institute manner, at least as individual professionals, we should mark what we have learned, what is the your takeaway point, and what you are going to invest in our area of concern, and so that when we come next time, we can share our ideas of practicality, of execution, of implementability of that particular idea. So this is one thing I think we should focus upon. Another thing is when we speak about the mining or when we speak about any industry, perhaps there was a time when it was something like we took some resources, utilized the a particular part of it and left the other thing as it is wherever it was. But this concept of circular economy is definitely, making us feel more and more conscious and clear about the resource crunch. Perhaps the way we are thinking about researching of some critical minerals or valuable minerals, I would say, or strategic minerals, in dumps and wastes of normal bulk material or normal process sludges or process outputs. So this is, nothing but a part of circular economy. So I feel that one kind of comprehensiveness which can be introduced in the field of mining, that whenever we do mine and whenever we do process anything, not only that product should have a specification, even the byproducts or I would not use the word waste because waste is considered as wealth these days, whatever be the byproduct and you can say the other products, that should also have, then and there, the analysis of that element. So that it is not left to that after 40 years you are going to analyze the sludge of electrolytic manganese dioxide cell. So if chemistry is written on first stroke that this was having so much of carbon, this was so much of copper, then perhaps you have that specification clear with you. And as they say in ISO and as they say in any industrial practice, that you should do it first time right, and that is the right time. No subsequent handling, no multiple handling. So whenever you are keeping a product or byproduct anywhere, you should have a full clear-cut analysis and tagged on it so that something which is not important today will become important tomorrow, and you know what is kept where, whatever we have explored. So these are two, three things which I wanted to mention and I wanted to share with the mining fraternity. My basic allegiance is to steel industry, that is, and their circularity and waste management is key. And more so the current level when steel production is so much, so there's so much of competition, so you have to work on each and every milligram of your resources. So I think that waste to wealth concept is to be brought in a very powerful manner in mining industry, and rather you can say in all walks of life. So that waste is wealth is, I think, the key term for any of the sectors or industry. With this, I must thank and congratulate the chapter and all the participants, and I am sure that they had very good time. And as I have requested, please jot down, not for anyone else, but for yourself, 2 points which you have learnt and 2 points which you are going to implement in your industry, so that the discussion next time is more fruitful than this time. Thank you very much.
Thank you so much, sir. Truly grateful for your valuable perspectives. The journey that began with Shri Piyush Narayan Sharma's opening words now comes full circle as he returns to share the final reflections. With a warm round of applause, I would like to invite Shri Piyush Narayan Sharma to enlighten the gathering with his words.
Thank you. Indeed, I have honored to be in the company of two stalwarts from our mining fraternity, or our CMD, Shri Indradev Narayanji, CMD Shri Saxena Sahab. And even more heartening is that the kind of presence it is there till the last. This itself is the testament of how the things have gone over the 2 days. And I think sincerely my thanks are due to all the people, those who have been behind this successful organization, specifically to our Dr. Yogesh Kale, his team, and indeed all of you, those who are the part today, those who are present here, without drooping, keeping alert, and wonderful presence of yours. created the whole difference. You know, we have been talking a lot of things over the couple of days, and one word is very prominent, and that is technology. Technology and technology. Sometimes, you know, there is other side of the technology. This morning itself, you know, let me tell you a little, conversation which I had with my son. He was recommending a movie to me. Then he said, probably you may not like that movie, because I'm a person from the old school of thought. Those were the times I still remember. Because the horizon of the technology, how it has expanded, is just I can tell you, you know, when we were growing and we were in the college, there was nothing like, you know, fast-paced technology. Even when we were, like I still remember, Saxena Saab, my first selection, campus selection was in the Moyle, which eventually I didn't join, as a matter of fact. So, the thing is that if you are somewhere, specifically being a mining person or working there, it used to take several days to reach information from one place to the other, because we were not having the direct lines to talk to our families. We were having no other means of communication. It was only the great letter. The art of letter writing is now gone with the wind, I do believe. So those were the times. And now today, when I am standing in front of you, probably our switched off phone listens what we are talking about. Sometimes it is a dreadful thing, isn't it? So today morning he was telling me that there is a dark movie probably which you may not like. He said that I just forgot the name of that movie. He said that people in the future will be identified or will be paid in the terms of the likes they get from the society. And those who don't get the likes, they'll be prisoners. It's a dreadful thing. And I really, you know, thought about it. It can happen any day. Because today we were also seeing, you know, everywhere, if you look at the, though I am lucky not, I'm not on Instagram or Twitter or anything else, but you look at where you have right now, where you are going, what you are doing, everything is there in the open. There is no more a secret. Technology is very intrusive. It is disruptive. And sometimes it is dreadful as well. So this is one aspect of the technology, but now it has become a part of our life. We can't do away with the technology. There always are the two sides of a coin. One is probably like nuclear energy. A wonderful side and a very dangerous side as well. Now it depends upon all of us, how we want to use it, how we want to utilize it, because the snake poison is also a remedy for the snake bite as well. So these are the things which we have to very carefully think about and take it to the future generations, as Saxena Sahab has very rightly placed in front of all of you, and he has been doing it since last some time. Yes, of course. We have taken everything, our entire ecosystem on loan, and we have to return it back with some kind of a due interest. That is the responsibility which lies on our shoulder, and that is the reason that we are here. I still remember, you know, in the opening session, I also expressed one view, you know. There is one thing, you know, if I want to place before this August gathering, because I understand, you know, when I was in the Hyderabad, then there was a issue of recognition of some sort of a CRISCO guidelines and all those things, and MEI has been, you know, trying it out since last so many years, and they want that people like us, though, who can, you know, take it to the ministry and everything, they should help in this endeavor and everything. I have a little different view on this. If you look at the, when Jio was introduced in this country, It was free of cost. Everybody was happy to have it. Now they have started charging. And don't take it time in a virtual sense. When most of us, when we joined colleges, we were very naive. We never knew what the liquor is all about. And most of us started having it. पहले दोस्तों ने पिलाया फ्री में, बाद में खुद खरीद के पीने लगे. इसी तरह से रिलायंस ने किया. These are the strategies, they do it. आपको कोई आदत डालते हैं, उसके बाद में आप उसको अडॉप्ट करते हैं. And technology is also something like that. We can't, मेरे जैसा आदमी जब ये नहीं सोच सकता that I can do very well live with my life without my mobile phone, then I can't complain. This is reality and it has to stay here. We cannot run away from the technological interventions. We have to think positively and we have to take it and adopt it positively. That is the key thing. Now, another thing is that when I said in the opening session that we must find out the solutions within ourselves, within the given circumstances, within the given ecosystem, that is what best we can do. Similarly, I still, propose one thing to the MEIA specifically. They are propagating this fundamental framework. They have already linked it with the different, JORC, they said the CRISCO guideline is there, UNFC, that is guideline is there. They have already developed a template. They want it to be recognized. I want to tell you in a different way. Please do one thing. Please be Reliance. Please be your old college friends. Develop a template. Float it. What Meta is doing, what AI is doing. They have provided the free platforms. They are giving you the access to improve them. And that is where the true wealth lies. If you have developed a system and you have free floated it, and if it's good enough you think, then people will join you, they'll give their own ideas. And if it is good enough, then it will start floating on its own. And I tell you, it is my belief that gradually it will become an accepted norm and people will be forced to adopt it. So that is the power of creating something without fear. Because what I believe in is that those who are creating it, those who are initiating it, those who are the inventor, they will always be a step ahead. So don't fear that somebody will take it off, somebody will become more intelligent than you. You will always be a step ahead of everyone. You will be the person who will see probably 10 times ahead of what people using your platform can think about. So my entire thinking as of today's world, I do believe that, and I pray to the God that technology never overtakes the human beings on this earth. They should always be up a step ahead of the technology. And I truly believe that it is going to happen. But yes, of course, you cannot ignore this part as well. So the idea is that be open to experiment, because there is nothing which has been created in this world which we can say is of no use. Even a criticism, even a failure, even not able to achieve something probably is the genesis of a story which will unfold in the future like a beautiful story of tomorrow. So that is the key takeaway. Why we gather here, that is what I truly support. Saxena Saab told that we must be able to maintain a continuity of what we are doing today. That is the most important part. So this is what, my heartfelt appreciation to all of you. Your presence made the entire thing so graceful. You were so eloquent in your expressions, in your thought process, and in what you feel. So that is what keeps all of us going. And I always can bow down in front of you because you are the one who show us the path, who give us the inspiration, who are the source of energy for all of us. At the end, I can only say that waste is nothing, as Saxena Sahab says. And at the same time, I say, impossible is nothing. Thank you.
Thank you, sir. Thank you for lighting the way forward. Now, as a token of our deep appreciation, it is now time to present memento to our dignitaries to honor their contribution and presence here today. May I please request Dr. Y.G. Kale to present a memento to our chief guest, Shri Ajit Kumar Saxena, CMD MOIL, as a symbol of our heartfelt appreciation. Thank you. Thank you for gracing us with your presence. I once again request Dr. Y.G. Kale to kindly present a token of gratitude to Shri I.D. Narayan, CMD MECL. May I now request Dr. Y.G. Kale to extend our token of respect to Shri Piyush Narayan Sharma, Controller General, Indian Bureau of Mines. Thank you so much. This gathering is graced by the presence of Shri M. Narsaya, Secretary General, MEAI, National Council. We take the pleasure to honor him. I invite him on stage, and to extend our regards, I would request Dr. Y.G. Kale. Thank you. I now want to take you down the memory lane through a video. Here's a glimpse of the moments we shared over last 2 days of the seminar. Can we have the video, please? Thank you. Thank you so much for this beautiful recap. As we draw this impactful event to a close, it is time to acknowledge the contributions of all those who made this seminar possible. It is my pleasure to call upon Shri Ashish Mishra, Deputy Controller of Mines, Indian Bureau of Mines, and Organizing Secretary to extend the vote of thanks.
Respected sirs, before I commence, there is an important announcement and I would like to invite Dr. Y.G. Kale for the same. Sir, please.
A very good evening to all. Before proposing the vote of thanks by Mr. Ashish Mishra, friends, I would like to tell that from the last 2 days, we have a very effective anchoring on our host, Ms. Srushti Singh. She has very effectively managed and kept us alive with her lucid manner anchoring. So, Mining Engineers Association of India Nagpur chapter appreciates her efforts and dedication for the last 2 days and for very preparations. So, I request Chairman of the Nagpur chapter, Shri P.N. Sharma Saab, to felicitate her with the bouquet and a small memento. Thank you, sir. And over to Ashish Mishra, please. Now.
Thank you, sir. Respected dignitaries on the dais, Honorable Chief Guest Shri Ajit Kumar Saxena Saab, CMD MOIL. मुझे अभी पता चला कि आप मेरे ही कॉलेज के एल्यूमिनस हैं, सर. Respected guest of honor, Shri Indradev Narayan sir, CMD MECL. Esteemed President of the session, Shri Piyush Narayan Sharma Saab, Controller General and Chairman of MEI Nagpur chapter. Distinguished dignitaries on and off the dais, learned delegates, media representatives, respected sponsors, organizing team and dear guests. Good afternoon, rather good evening. It is my great honor and privilege to deliver the vote of thanks on behalf of MEI Nagpur chapter as we conclude this intellectually rich and inspiring 2 days national seminar on Indian mining, present scenario and future perspective. There is so much to speak about and listen about critical minerals and sustainable mining, and we have listened enough, but the first thought at the conclusion of this seminar that comes to my mind is abhi to kuch kaha nahi, abhi to kuch suna nahi. It was quite inspiring to see the participation of youngsters in this event and their views on critical minerals and circular economy that we deal at our offices at ministry level, but youngsters are very good at it, very good. To begin with, we express our deepest gratitude to the chief guest, Shri Ajit Kumar Saxena Saab, CMD MOIL, for your gracious presence and sharing your visionary thoughts, sir. Your valuable insights on intergenerational equity and your suggestions regarding waste to wealth and feedback after this seminar are well taken, sir, and we will try to address these issues. Thank you, sir. Our sincere thanks to guest of honor, Shri Indradev Narayan, sir, CMD MECL, for joining us and enriching the session with your thoughts on mineral exploration and the future direction of Indian mining landscape. Thank you, sir. We are equally grateful to Shri Piyush Narayan Sharma Saab, our Controller General IBM and Chairman MEI Nagpur chapter, for presiding over this session and for his unwavering support and encouragement. Sir, your guidance and leadership have been a true pillar and a strength for conduction of this seminar. Thank you, sir. A heartfelt thanks to all our eminent speakers, paper presenters, panelists, session chairs for your scholarly contribution. Thank you. We owe a special depth of gratitude to our secretary, Dr. Y.G. Kale, sir, controller of mines. Sir, your tireless efforts, precise coordination, and passionate commitment have the driving force behind conduction of this seminar. Thank you, sir. Thank you very much. A warm appreciation goes to all our patrons, conveners, member of organizing committee whose hard work behind the scenes have made this seminar a resounding success. We extend our sincere thanks to our esteemed sponsors whose generous support and partnership have been crucial in enabling the smooth and successful conduct of this seminar. Thanks to all the sponsors. Thank you. A special mention to the press and media representative. Thank you for covering this event with such diligence and professionalism. Your efforts in bringing the outcomes of this seminar to a wider audience are commendable and invaluable. Thank you. We are also thankful to the management and staff of Hotel Radisson Blu, Nagpur, for your warm hospitality and impeccable arrangements. Thank you very much. Thanks to all our delegates, guests, participants, senior industry representatives, and a special thanks to Secretary General, sir, for taking time and coming here, sir. Thank you very much. I want to especially mention two key persons who have made this seminar a grand success with their hard work. One is my friend and colleague, Shri Arun Chechane ji. 15 दिन से उन्होंने इतनी मेहनत की है, वो मेरे बगल में ही बैठते हैं, मैं देखता हूँ. He really I want to thank him from the bottom of my heart. And second is Ms. Srishti Singh, our host of the event, who has efficiently steered the whole event and kept you alive. As we part ways, let us carry forward the insights, connections, and resolve to contribute a progressive, responsible, and sustainable Indian mining sector. With heartfelt gratitude to each one of you. Jai Hind. Thank you.
Thank you so much for your word of acknowledgement. Ladies and gentlemen, before we disperse, I would invite you for the high tea. Thank you. May I have your attention, please? We have found a ring. If it belongs to you, please take it from us. It's a red coral ring. Thank you.